yeah. So hopefully that we have opportunity to talk again. Thank you.
Yeah, this is a video.
Yeah.
It's just a video, right?
So if it goes there, everything's okay.
Yeah.
I see.
Oh yeah.
Hello. How? I'm Scotty. Hello, nice to meet you. Nice to meet you. Yeah.
Yes. Before I teach data over
Evangelion. That's how they do it in Japanese.
Oh really? Yeah, we both are lovely of
Because some people.
we both are.
My major is design.
But the Japanese people is like
My colleague belongs to the University Library and School of Agriculture.
I don't know if you saw behind.
In Chinese.
There's this one.
We are bad in Japanese,
So
right?
basically, it's a mic check, and I'm gonna
Oh yeah.
no problem. Like you just have to read out loud. My name is Scotty Paul. The title of my job is blah blah blah, and just like read it off. It will be kind of like a microphone check. But I will
before talk or now?
exactly
Before the talk.
I'll start the presentation, and I'll let you know when you have to begin.
So do I have to follow exactly? Because one of the slides I also introduce myself.
Yeah, no, it's just for like the microphone check.
A microphone check.
Yeah.
Oh.
And it's just like that you agree to having your picture taken because it's recorded. So they want to make sure that they hear you correctly.
Oh. Okay.
Is it okay?
Sure. So when the audience here, I'll read this. That's quite
But
real.
I'll tell you beforehand.
Oh, okay.
No worries.
Oh, okay.
So I'm gonna do like, hi, welcome everybody. We're gonna hear a talk about blah blah. And then I'll say, now the speaker will do the mic check. And then you would have to read this. And then I'm gonna say, okay, now we're gonna start.
Okay.
So I'll guide you through this.
I see. Okay. No problem. Let me check the display first. No, because I want to show. I want to show my code and the slide. So the slide is like this. The code is in here.
And it's corresponding to.
Yes.
I think
so. If you can mirror your displays, that's probably the easiest.
Is it?
Yeah, I think this display is corresponding with the main screen.
Okay. Then I have to mirror. Yeah. Okay.
Yeah, there we go.
Oh, thanks. Yeah.
And that way you should be able to. You might want to resize. I don't know, because it's big enough. It might be okay.
Yeah. The font size. Yeah.
I mean, to make it more pleasant for you.
Yeah. Thank you.
I'm looking forward to the talk.
Oh, thanks.
Okay, so now you explain, but somehow it doesn't receive the signal.
Oh, that's not recognize. How about now? I changed it to
Yeah,
mirror.
so this side seems okay, but it doesn't.
Oh, I see.
The signal doesn't go there.
Okay,
Right now.
okay. Yeah, because it's distorted. It's quite weird. It's but I don't know how to change.
What resolution should it be at? Maybe it's a.
It's a probably the.
Is it this one?
This event, this conference, or this talk especially, you can use the hashtags there. So PyCon APAC _1 for this talk, or any other talks that will go on in this room, and PyCon APAC in general for this conference. So we'll start in a few minutes. Okay, again, welcome everybody to this talk. We're gonna start the first presentation of this track from Scotty Kwok, and the title is Reproduce Evangelion Timer on Browsers Using PyScript. So before we start the talk, we have to do a quick mic check, so I'm gonna ask Scotty to read out the statement, and the presentation will start after that.
So, my name is Scotty Kwok. The title of my talk is Reproduce Evangelion Timer on Browsers Using PyScript. My presentation will be in English. The presentation materials are in English, and I will publish the presentation materials. I agree to have my picture taken during my presentation, and I will compile with the PyConjp Code of Conduct.
Thank you so much. Okay, we're going to start the talk now. The presentation time is 30 minutes, and within the 30 minutes, there will be 5 minutes at the end for a Q&A session. So if you have any questions, we'll go around with a microphone, and feel free to ask questions. So here you go.
Thank you. So, good morning and welcome everybody to my talk today. Today I will talk about how to reproduce Evangelion timer on browsers using PyScript. So first of all, can you put up your hand if you know what is Evangelion? Anyone know what is Evangelion? Okay, I'm relieved. At least you know, some of you know what is Evangelion. So a bit of introduction about myself. My name is Scotty. I came from Hong Kong. I'm a speaker and also organizing committee member of PyCon Hong Kong. And I will call myself a software developer. I'm actually now working in a company called Sebit, which is a IT solution company that I found with my founders. A little bit about my company, Sebit. It is based in Hong Kong, and we build customized computer vision and AI solution for our customer. Our customer includes some like government organization, railway operators, and lift and escalator companies. By the way, we are hiring, so if you're interested to work in Hong Kong, please feel free to reach out to me and check out our website. Okay. Now today's the topic is Evangelion timer implement using PyScript. So let's start. So the agenda, we'll first take a close look at the Evangelion timer design itself, and then I'll explain how to reproduce the graphical components. Then I'll talk about how to program it, and then we'll see what it looks like after putting them together, and then we'll discuss some of the lessons learned, okay? And the slides is you can get it from this QR code or the link here. Now let's take a closer look. Okay, so we all know that Evangelion is a giant robot powered by electricity cable. So when the cable is broken, that's when the timer starts ticking. Because now the robot is powered by battery, internal battery, which only lasts for briefly a few minutes. And in the last, 60 seconds, time is running out, so the timer will turn into red color to indicate emergency, and Shinji will start crying from that moment onward, okay? And everything went wrong from that point on, okay? Okay, then finally the time ran out, and then the timer stopped at the 0 seconds. So that's the free transition of the GUI that I've shown here, from external to internal, from internal to emergency, and then stopped. And by the way, if you want to look at more examples, please check out another repo, Evangelion timer and analysis. I listed out most of the appearance of this timer. And one interesting fact, and another reason why I want to try this is because, Evangelion has been in production for 26 years, right? So there are at least 2 series of it. The Neo Genesis Evangelion back in 1997, and then 10 years later, another rebuild series. So even the timer design itself has changed over this long period of time. It probably is showing a different preference of graphical design, because perhaps the designer try to catch up with the preference of their audience. So in the new timer, you see a different color is being used, and a different fonts is being used, which may look like slightly modern, perhaps. But anyway, the way it is animated is kind of similar. And it still capture my attention a lot. Like another interesting thing in the new rebuild movie, there are a few more design being retrieved when the story progresses. So when the robot is in a standby mode, there's an auxiliary mode here, and in the beast mode, there's another completely red timer with glitches and noise. And the most interesting one that I think is when ask her, we call her memory during training. So there's a version of the timer where it's a very vintage color, and then the language is in German. So you see that I think the design teams have spent some decent effort to make this timer look real. Now, apart from me, I think some other people also tried to implement this timer on the internet. So if you Google Evangelion timer, you'll see different implementation in the past. Now today we'll do the same, but we'll do it on browsers and using Python, okay? So how do we reproduce those components? First of all, I want to answer the question how we remove the projective transform of this image, because in the anime, the graphic is tilted, like it's a projected view. So in order to reconstruct the graphic, I think it's better to remove the projection. So it turns out it's a very simple problem, well-studied problem called homography. Basically, by finding the homographic transform, we can transform between the projected and the non-projected view by applying the H or the H inverse. H is the homographic matrix. Now, this is a piece of code in scikit-learn or scikit-image, in case you want to try it later. Basically, we read the image, and then we create 4 anchor points. We tweak the 4 anchor points, and you can get a decent estimation of the projective matrix. Then you can apply the inverse. Then what you get is a non-projected version of it. Now, from this part, then we can then build, analyze those components. And here, I list out all the components involved. Now, to start with, perhaps the most eye-catching one is the background color, which is a gradient color field, consists of red, yellow, and green. And then on top of this gradient background, there are many decorative dots. So this dots is actually a characteristic of Evangelion animation, because in other GUI, in the anime, they all consist of a lot of dots. And then one special thing is those panels, it consists of many irregular borders. So this is a nightmare for HTML design, like irregular border. And then when it comes to the fonts, I selected 3 fonts, tried to reproduce the original one. For the Japanese font, I took the Zen Antique, which is publicly available in Google Fonts API. And then for English fonts, I think the exact font is the Arial Round MT. And then the old style 7-segment LCD font is used to show the time. Now, okay, the headache for a developer is how to put these parts in place, like in the correct place, because they're irregular. And then you want to put it precisely in place so that you can reproduce the original feeling. If you know about some other JS framework, like React, Vue.js, etc., I think it's not designed for this purpose. So at the beginning, I think it's not feasible. But then later on, I figure out there's one way to do it, is the scalable vector graphic. So in case you don't know about this graphical format, this is an image format, but it's not in pixels. It is actually in it's like a drawing instructions. Basically, you specify drawing instructions, then the browser will then render the graph according to your instruction. Here's a simple example. Using SVG, we can instruct the browser to draw a circle with a certain color and the stroke size. Then the browser will render the graphic. So that's how we do the layout of irregular components. And I use tools like Adobe Illustrator to draw it. It's very common if you're like designer. I think you know Adobe Illustrator more than me. And for people who want to try free tools, perhaps Inkscape is another one. And here I want to show you how I did it in Adobe Illustrator. So this is the Adobe Illustrator artboard. Sorry. Now I start with putting the image that I prepared earlier by removing the projective transform, put it in the background as a guideline. Then I start drawing those other vector components on top of it, like those external buttons, and then internal buttons, and then the active time remaining tags. And then I draw the digits, as well as those irregular border. Then I add the dots, decorative dots. And then finally is the background. So now we end up have reproduced almost all the graphic. So what you get is something like this inside of the Illustrator, which is a document that describes the graphic. Then now you can export it as a SVG file and then put it into your website. Now one of the beauty of doing so is that if you put the vector graphic versus the original graphic side by side, I think you agree with me that they're almost exactly the same. I mean, there's some difference in the fonts if you are careful enough, but they are like 90% the same. So that's the beauty of using SVG. You can lay out exactly in position whatever you want, whatever color. And then another beauty of SVG is that it is scalable. So when you open it on the browser, you can scale it up, scale it down, whatever size you like, and there are no distortion in the image. So even you open it on a huge screen, I'm sure you will not have any image quality degrade because this is a vector graphic. Now, before I move on to talk about the programming, one thing to remind, in case you're going to do something similar in future, make sure when you prepare your SVG file, you organize your element in a logical way. So you group them logically, you name your elements in a consistent name, because this is not just an image. This is actually a document that we're going to program later on. So the names and the grouping need to be organized. Then we can program on it. Okay, then move on to the tough part, the coding part. So the whole time actually took me quite some time and a lot of code. So today I cannot cover all of them, but I selected some of the key concepts and simplified to show it here. The code in this section is available in these QR code or in this link. Is in my GitHub, so you can try it together if you like on this code. Okay. So inside this folder, I showed some examples. The first one is PyScript, like today's topic. In case you have not heard about PyScript, PyScript is not a new language. It is just a framework that you can embed into your HTML, and it will run Python script. So how do we do it? Let's do it together. So show my ID. So okay, so this is basically the piece of code. Then now all you need to do is just prepare HTML file. Then you add these two lines in your header. Then you include the PyScript.js and PyScript.css. Now then, you can then start writing your program using this PyScript tag. Like here, I print hello world, and let's see what we get when we run it. Now see, this is okay, let me zoom in. Hello world from PyScript, print from the Python code. So it's very simple. Now, okay, now you can then start to play with it. Like let's say you want to repeat it 10 times. Now it gets repeated 10 times. So that's how easy it is to start a PyScript programming. Just include this header. Then you can start do some Python programming. Then we move on back to what I want to discuss is to use PyScript to manipulate the DOM. But first of all, let me explain what is the DOM. So how a browser works actually, when you use a browser to go to a certain web page, it will load the HTML file and the CSS file. And those files will be consumed into memory and construct a tree called DOM tree and CSOM tree. Basically, that means the document object model and the cascade style sheet object model. So the browser will combine these two trees to construct the render tree. And the render tree is what is being displayed finally to the user. So as a programmer, basically, you can write program to manipulate this DOM tree. Then you can control what's being displayed to the user. And that's what many JavaScript library also do. So now today we'll use PyScript to manipulate this DOM tree. How we do it? Okay, let's do it together on here. Now this is an example of how to manipulate DOM tree. This time, apart from the PyScript header, I define an HTML layer in HTML. Let's call it container. Then in the PyScript tag, you can then now import document from the JavaScript, and in the document you can then use query selector to select the elements that we defined. For example, this time we select the container element, and what you're given is a pointer to the HTML element, and then at that point onward you can manipulate the content of it. For example, here I'm trying to assign the Python version, output it to the inner HTML. Now let's see what you get. Here, Python version 3.10.2. So this is the Python runtime created by the PyScript. And this version is now embedded into this inner HTML of this layer. And that's how easy it is you can start to manipulate the HTML elements using PyScript. Now, strictly speaking, this is not PyScript. This part is actually PyODI, so which is the back end of the PyScript. But anyway, it is a way that you can call JavaScript functions. Okay. Now, based on this method, now you can do something more interesting. Now, the next example I'm going to show is how we load a SVG file. Using the same method, but this time I prepare a logo, a SVG file logo, and then what I do, I just need to read it using OpenURL, and then I like this return the text of this file, and I just assign it to the inner HTML, and that's what you get. So a logo embedded directly loaded on the HTML. So further on that, what you could do, you can then start adding some kind of manipulation. Now we can transform the style of it. For example, here I add a projective transform and rotate the X and C axis. Now what you can get from here is now a projected image with rotations. Basically, the browser will render the transformation according to the spec you put in here. That's how easy it is to further manipulate SVG. More on that, what you can do is here, I prepare animation cascade style sheet, which is a class I call it blank. And by adding, this blank is actually an animation that repeats infinitely, and it is an alternation between visible and invisible. And now the way to do it is to add this class into the class list of the element. Now then this element will then start blinking. So let's see what happens. Now you end up have a logo that animate according to the cascade style sheet that you define. This time is flashing or blinking. So using the same concept, there are lots of things you can do. Let me show, sorry. Now, this is one you can try on your phone or your browser. So I try to combine them together. So you can load your logo dynamically by, on the fly. And then you can do resize of the logo. And you can also change the opacity, that's the transparency of the logo, using the style. And you can also do rotations, and then some more animation, for example, make it breathe like this, and you can change the logo dynamically and make it blank, or you can make it roll. So basically, you can mix and match many kind of animation onto the SVG file. Now that's how I get it done. Get the graphic done. And I think another thing is how to make it a buttons in SVG. Okay. Now earlier I talked about we need to name the group, name the elements and group it correctly. So this is how we do it. For example, this time I want to make one of the SVG element as a button. Then the way I do is that I use query selector, select that region or that group. Then I add a clickable animation to that group. And then we can register a click event listener. Now, this is very much like a JavaScript way to do it. You register a callback function. So when it's being clicked, your callback will be invoked. And because this is a merge of Python and JavaScript. So you need to use create proxy to warp your callback function, because the underneath is actually a JavaScript function is used. So this create proxy is a PyODI thing that you can use to warp your Python function. Now what you get is that now the component will become clickable. And when you click it, the function will be called back. Now using this method, you can convert whatever elements in the SVG into buttons. So that's how most of the basic concept of how to construct the timer. Now let's move on to one important thing. Okay, finally is how the core logic work. Here I need to bring on another concept, which is asynchronous programming, because I think usually when we learn Python, we do asynchronous programming, but when it comes to browser and front end, it's more preferred to use asynchronous. Now assume we want to have a certain thread or certain while loop keep running in the background, and then it take the current system time every 0.05 second and print the system time on the browser. Then the way to do it in asynchronous mode is that you put your while loop inside a function and declare it as async. Now then you can sleep. When you do sleep, you need to use await async IO sleep so that it sleep the asynchronous time. And to start it, you use ensure future to kick it off. Now what you get is, without creating another thread, but the asynchronous loop keep going by itself and without blocking the main thread. Now, it's quite important that in the front-end development in web browser, we need to use asynchronous, because otherwise you will block the main thread and make the GUI frozen. So make sure you check out asynchronous programming if you want to do this kind of animation. Then I do some kind of refactoring because there are too many code. So in case later on you want to check it out, I refactor it to make it quite easy to create a layer and then easy to load SVG. And then like in just one line, you can convert a certain group into a button and then add a callback to that button. Now, okay, after a lot of hard work, that's what it looks like at the end. Maybe I can do it together. So, okay, here's the outcome. We have a web app that can be loaded on the web browser. Okay, you can do start countdown. You can pause it, and then, okay, we can change it to count up. Okay, and we can change it to show system time. And then you can toggle to projective transform, because this is very easy, just as I explained, just a cascade style sheet class. And some browsers support full screen, so you can do full screen. And what else? And okay, make it more fun, I add a setting page. Now you can change the countdown time to something else, so that, okay, like you can count down in a different duration. Okay, and also because this is SVG, very easy to change the style. You can play around with different style, like grayscale, and then you can show only the wireframe, because it's all just about styling the graphic. And also, so happen I start to create the new version, the new review GUI. It's like, it's still work in progress. It's not exactly the same, but kind of okay. So that's basically the outcome of this project. So to go back to some of the takeaway I want to explain. First of all, okay, it is a pain to write PyScript in VS Code because the support is quite bad. I mean, there are some extensions that you can install. Okay, actually the extension give me some good syntax highlight, which I'm happy. But then it also break some of the native HTML language support. Because after I enable the extension, some of the, let's say, even formatting a document, the menu is lost. Like live server is lost. So there's some conflict, basically. Perhaps we need to wait for a proper support from VS Code. So for now, you need to like be careful when you write PyScript on the IDE. And there are no linting. So if you write a Python script and then you import PyODI, import JS, there are no linting. So you're now on your own. No auto-completion, no code checking. So good luck. And one more important thing is the performance, because I also try to implement it in JavaScript. I find it load much faster, and it's much slower in PyScript. And why? So I try to use, let's say, Lighthouse to analyze the performance of just PyScript Hello World. Look, you know, PyScript Hello World is doing nothing, just load the PyScript. But the performance is already quite bad. And the reason being, like, it's loading a huge amount of data in the PyODI backend, and the PyScript itself is taking 4 seconds to load. So I think this is also a well-known problem in the PyScript community. Hopefully there will be some solution, some improvement later on. Or perhaps when our phone gets faster, this is no longer an issue. Okay. So finally, conclusion is that, okay, PyScript and actually PyODI, I should say PyScript and PyODI are fun and easy to learn. And then I think SVG is kind of a hidden gem in web development stack that everyone can try to play with it. It's not very popular, but it allows you to lay out irregular components. And then it can be like added to the DOM tree, then you can style it, you can program it, and you can animate it along what you want. So it's very flexible. And finally, I think even though PyScript had some limitation, but I think combining it with HTML, Cascade Style Sheet, and even SVG give us a lot of other, many possibilities. So that's, and here are some links, materials that I used today that you can check out later on. And it comes to the Q&A section, okay? And thank you for listening to the talk. The time is just right? Yeah. Okay, perfect, okay.
Thank you again for the talk.
Okay.
So if anybody has any questions, feel free to raise your hand and we'll go around.
How many time do we have?
We have 5 minutes.
5 minutes. Okay. Okay, just one moment. Yeah, please go ahead, please go ahead. Please go ahead.
Thank you for your great presentation. Sorry, can I ask you thank you. Thank you for your great presentation. It was very interesting and exciting. So I'd like to ask you about the performance. You mentioned the bot performance. Can you hear me? Okay.
Mention, louder. A bit louder.
Okay, sorry. Can you hear me now?
Yeah,
So thank you for your presentation. And I'd like to ask you about the performance. You mentioned the reason of the bot performance is loading the PyScript outside of your server, I think. So I think so if you serve the PyScript.js or PyScript.css from your server, the performance got better. Am I right? Or did you try that?
Can you repeat, try which one? Sorry, the PyScript.js?
You mentioned the reason of the bad performance is serving the PyScript.js from PyScript.net server. So if you serve these files from your server, I think the performance will get better.
Oh, you mean load the PyScript.js from another CDN?
CDN or
I see.
your local, your own server.
Yeah, maybe I can try it. So far, I also tried, actually, not just the loading, not just the download take time, but also the loading of that PyScript runtime take time. Because I tried to cache, also tried to, that's one way that you can download all the PyODI and PyScript.js locally in your server. And then you serve this PyScript.js and the PyODI from your server. But it seems not a big improvement in my case. Perhaps the load time is also cannot be avoided. Yeah, unless there are some improvement.
Got it. Makes sense. Thank you.
Okay, any other questions? In the front.
Hello. Thank you for this amazing talk. So I have a few questions. One of them is that can we import other Python third-party library? Although I know it's slow enough. If we import pandas, it might become even slower. So, but yeah, because we are going to play some interesting things. So I'm curious where we can import it. And another question is where it's production ready according to its performance, I guess not. But I want to make sure that, so that's the second one. And the third one is that when refreshing this page, it's loading the PyScript. I try to select all the text in the browser, and I seem to see the configuration of this page. Is that expected?
But does it eventually load it? Does it finally load it?
It's finally loaded, but
Okay.
During the loading time, I just randomly try to select all the texts and I found out something interesting.
Yeah. The thing is, yes, when it's loading, there's a splash screen showing the status. And sometimes when your internet is really slow, you also see the code display on the screen. So it's quite annoying. So I mean, I didn't figure out how to do it, but maybe there are ways to disable it. I mean, before the program really complete the initialization, there's a moment the browser will display the code directly. Yeah. So it happens to some of the machine or some of the internet speed is slightly slower. So I don't have a solution yet, but I think that you can disable the splash screens in PyScript. So the initial loading circle will disappear. You can disable the splash screen. Perhaps that will help. Yeah. And then back to the second question is, sorry, can you repeat this?
Where it's production ready?
Oh, I think according to them, it's not for production. It is beta. So it's his very first attempt to make a complex thing like this. I think usually you check out their tutorial, it's very simple, hello world examples, and they claim it's still not for production. And bear in mind the API will also change. I found that they change the API function names from time to time. So if you use it for production, I think, yeah, need to be at your own risk. And your first question is
it possible to import other third-party library like NumPy or Pandas?
Oh, for other libraries, yeah, good question. I think you can import any Python library that is written completely pure Python. So in the PyScript website, you can check out they mentioned there are a few common libraries, like I think NumPy and Pandas should be available as well. Should be able to load it. But I think they port a certain version, which is a pure Python version. So that it can be low in the browser. But there are many limitations, as you may aware. It's slower, and then not all the library can be loaded. Only a small amount, a certain amount of it. But I think it's good enough for some of the basic testing and trying and learning it. Yeah, but not all.
Yeah, thank you for this amazing talk. Yeah.
One more question over there.
I think the time is up. Unfortunately, we have to end the session here. I'm sorry.
Okay.
First of all, please give a big round of applause for our speaker.
Thank you.
Thanks again for your presentation. And I'm sure if you have more questions, you can talk to him after the session in the hallways. One more thing before we finish. I want to remind you that there is the sponsors in the first rooms in the entrance, so we encourage you to go visit them and go around. And also to remind you, there is on the back of your card, you have like a rewards card. So if you go to a bunch of booths, it's 6, I guess, or 7, you can get a gift at the end. So yeah, thank you again.
Hi everyone, welcome. If during the talk you want to tweet or whatever they call it now on X about PyConJP or PyCon APAC or about the talk in particular, if you can use the hashtag PyCon APAC_1 for this room, equivalent ones in the other tracks, and we'll get started shortly. Yes. Okay, so now we're going to start. Our speaker is Yuichiro Tachibana, and the topic for today is Streamlit meets WebAssembly. Before the presentation, the speaker is going to read a prepared statement as a microphone test. So you can start now.
My name is Yuichiro Tachibana. The title of my talk is Streamlit meets WebAssembly SDI. Okay. Should I start from beginning? Okay. My name is Yuichiro Tachibana. The title of my talk is Streamlit meets WebAssembly SDI. My presentation will be in English. The presentation materials are in English. I will publish the presentation materials, and I agree to having my picture taken during my presentation. I will comply with the PyConJP Code of Conduct. Thank you.
Okay, so the presentation time is going to be 30 minutes, 25 minutes for the talk, and 5 minutes for Q&A. Okay, over to you.
Oh, can I start?
Yes.
Well, thank you very much for your quick, wonderful introduction of me, and thank you, all of you, to be here. I'm excited to present my talk today, Streamlit meets WebAssembly SDI. First of all, I am Yuichiro Tachibana, who is a developer, software developer, who is using Python for several fields, including machine learning, data science, and web development, and so on. And I am also, I have been active in several OSS projects, including Streamlit. That will be one of the core topics of today's talk. Related to that, I recently have a job at Hugging Face with the role of advocacy of Streamlit and Gradio. So if you would like some Streamlit stickers or Hugging Face stickers, please come to here after this talk. I have so much amount of stickers, so please come to here to get one. Today, I would like to introduce the software named Streamlit. That is WebAssembly port, SDI. That is the WebAssembly port of Streamlit. But before we will take a closer look into SDI itself, please let me introduce Streamlit first and also discuss about its pros and cons. That will be also the background of birth of SDI. First of all, what is Streamlit? Have you ever heard of this framework? Have you ever tried out using it? Thank you very much. Probably 50%. Good. Thank you very much. So I'm going to introduce it shortly. Its official website says it is a faster way to build and share data apps. What does it mean? First of all, due to its unique but super convenient feature, it became one of the most popular pure Python web UI frameworks. Actually, you can find many interactive, ready-to-use, impressive applications or demos that are showcasing machine learning, data science, or more unique use cases that you can find in the gallery page of the official website like this. And let me get back to this introduction slide and focus on this sentence saying that Streamlit turns data scripts into shareable web apps in minutes, all in pure Python. No front-end experience required. So let's see what it means. Well, this is a demo video taken from its official website. The only thing you have to do is write only Python code without any front-end code. Then Streamlit converts these Python scripts into this kind of interactive and beautiful web application that has various kind of widgets like charts and this kind of interactive widgets and so on. And, oops, there's something different. But the point is, there are many, well, building blocks you can use to create and construct interactive web applications just by writing Python code. This is one of the core features, core benefits of Streamlit. That is, pure Python web UI framework. So it was a kind of a conceptual introduction of this framework. So let me provide more actual example. Please assume that we have a single Python script named app.py, which has the content like this, where we import Streamlit package at the alias st at the first line. Then we will call st.title function with hello world argument. By the way, in the world of Streamlit, we usually call this kind of st.something function as component. So let's say here, st.title component is called here. And in the next line, we also use st.text input component, and its return value is assigned to the variable name that will be also referred to in the next line inside the argument passed to st.write component. Then we are going to navigate to the shell, then run and execute this command, streamlit run command with an argument pointing to the input file app.py. Then the Streamlit server-side process spins up and start behaving as a web server that serves a web page, so that we can access that web server with your own web browser and use this interactive web application. There is no front-end coding, right? The application you obtained inside, in the application you have seen here, you found that there is a title component that we use inside the source code app.py here, and there is also text input, and there is also text output components. And one interesting theory is that you can input text data to the text input field, and when you hit enter key, the input text data will be automatically, reactively reflected to this text output field. This is interesting because what we have written in app.py was just a simple Python script that do not have reactive parts like callbacks. But Streamlit automatically converted this static or declarative script into a reactive application. This is, interesting thing about Streamlit. So let's see what it happens under the hood. When you execute Streamlit run command on the server, of course Python runtime will be launched, and Streamlit package will be loaded onto it, which has several parts, including web server, of course. Then, when you access to this web server from your web browser, at first, some static files will be loaded at the initial phase, including index.html, main.js, or something like that. Then, the front-end application will be started on your browser. That will dynamically render the front-end app. Also, this app will be responsible for dealing with user input or user interaction with the front-end applications. For example, when you click something or input some text data or whatever, front-end application will catch it and send it to the server. And inside the server, the script runner part will receive such kind of user input data and execute app.py. That is the file we have written. And the script runner will gather all the executed result and send it back to the front-end application, so that the front-end app will re-render or update the front-end application content. This is the, things happened behind this reactivity of Streamlit. It looks cool, right? But, the problem is here. We can see this architecture as a kind of a traditional or ordinary server-client architecture, right? So we can easily imagine that this has some drawbacks, especially in this modern era. For example, because it serves web pages from a web server and runs Python scripts on the server to process input data, because every business logic you written in Python is inside the browser, inside the server, so we cannot use this application, hosted Streamlit application in offline environment. Also, every data you upload to the Streamlit application must be sent to the remote host, but it sometimes violates your data privacy policy of your organization. But this is critical, especially in the application field of Streamlit that are typically data science or machine learning or something like that. Also, from the viewpoint of service developers, scalability and maintainability can be also a problem because we have to maintain the dynamic Python runtime on the server side. So, it's kind of a problematic, troublesome. So, here is where ST-Lite comes in, finally. ST-Lite is a port of Streamlit to WebAssembly with the concept of client-side execution. In other words, ST-Lite is a fork of Streamlit that runs completely on web browsers with the power of Pyodide. By the way, Pyodide is a Python distribution for the browser, and Node.js based on this WebAssembly. In other words, Pyodide is a C Python interpreter or runtime compiled for WebAssembly so that it can completely run on web browser. So as a result of the combination of these technologies, this server-client architecture could be converted into the serverless architecture completely, where you can find that every dynamic part written in Python are now running inside the browser entirely. So currently now the server is just a static file server that hosts only static files that will be loaded at the only initial phase, and every Python dynamic parts are running inside the web browser. This is amazing. As a result of this conversion of architecture, as a result of this serverless architecture, now we have obtained the offline capability, data privacy, scalability, maintainability, in addition to all features, all benefits of Streamlit. Also, now it runs on the web browsers. We have multi-platform portability, of course, because nowadays we can use web-based application on your laptop, smartphones, more wider range, wider kind of devices. So until now, I have been showing some conceptual explanations, so it's time to show the demo applications to see what we can do with ST-Lite or Streamlit itself. The first thing is this site. You can find this website by Googling ST-Lite sharing. This is website you can find from this URL. This is a web-based platform where you can write some code on the left side, and you can get a preview the Streamlit application of this source code from the right side here. Let's see what happens when you write some code in the code editor like this. The first example is st.slider, and like this. Once you save this source file here, the Streamlit application or ST-Lite application on the right side detect the change and automatically reload this source file, so that now we can see the slider of widgets appeared on the web application. Also, when you write your input value is this value with st.write text output component. Now, it's kind of small, but you can find the reactivity has been realized by the interactivity feature of Stream like this. Also, this interaction example app here, you can select from this leftmost side menu. you can see a wide range of possible stuff of Streamlit or ST-Lite runtime that contains more impressive demo applications, for example, animation things or chat plotting. Also, geodata-based map application is also here. And for data scientists, also dynamic table view of your data frame is also here. To be honest, these benefits are provided by Streamlit itself originally, so this is not the benefit of ST-Lite. But the important part here is that all of these stuff are running only inside the browser without any server-side component, server-side runtime. That is interesting. Next example is more media-centric stuff, media-oriented thing. That includes some image processing demo that receives some input image from my local web camera like this, and it applies some some type of image transformation, or applying some blur filter or something like that. I know this is kind of a trivial example in the image processing field, but interesting thing that we have to note here is that everything is running in the web browser, even including OpenCV or scikit-image or matplotlib here. It's still, this kind of a wider, well-used packages are now already available in this platform, or ST-Lite or Pyodite runtime. Well, I have some more demo applications that I would like to introduce here. Next is similar to the previous one, but the difference is the data type. That is a real-time video stream. I hope it works now. Well, this is a real-time image input demo with a real-time video stream. The reason why I'm providing this example to you now is that I think video or image data is a typical type of privacy-sensitive data. So this is the good example of showcasing the benefit of ST-Lite that realizes a completely client-side execution that never sends this kind of privacy-sensitive data to remote host. So, well, let me see. OK, I'm going to stop this process. And next example is transformer demo. By the way, have you ever heard of transformers? Transformers library developed by Hugging Face. Do you know transformers, or have you ever tried out? Cool. Oh, thank you very much. Probably 50%. Cool. Maybe my colleagues will be so glad to see this result. By the way, as you know, transformers are one of the most famous machine learning client library that originally runs on Python with some specific GPU-backed models. But we have some tool chains that can be run on completely on web browsers using its JavaScript fork transformer.js. So now you can finally see transformers.js.py. That is a port of transformers library that can run Pyodite runtime so that it can also run on ST-Lite. Here is a demo where you can see, here is a very simple, sentiment analysis demo that is backed by transformers machine learning model that only accept the text input and shows the output JSON file like this. But Sorry, it's kind of trivial. It's kind of trivial, but please, the takeaway from this example is that even Transformers library is now running inside the browser. Cool. So until now, I have been just showcasing the possible examples of ST-Lite or Pyodite. So let me introduce some available options to develop and deploy Streamlit applications with ST-Lite runtime so that you can use this technology by yourself. The first option is ST-Lite sharing that we already have seen this from this URL. But one more feature I would like to introduce in this context is that, is that sharing feature of this platform. Once you develop once you develop your own application on this web platform, every source code or every source data or even binary data will be decoded and serialized into a single string embedded into this URL. So you can send this entire URL, including the serialized string, to your colleague, friend, users, or your maybe boss, managers. Then they can open up this URL directly from their browsers, so that they can open up the entire web application, entire Streamlit application you have developed on ST-Lite sharing platform. This is good feature to share your Streamlit applications to your potential users, especially in the restrictive environment like offline or privacy-sensitive situations. But also, you have another option to hosting your own file to everywhere, including GitHub pages or Cloudflare pages or something like that, by writing a single HTML static file inside, in which you will import ST-Lite CSS and JS files. Then you can directly pass the Python source code as a string literal to ST-Lite API like this. This is looks like complex, but everything you have to do is just to copy and paste this source code snippet from the official README of ST-Lite repository. That's easy. So I hope some of you will host your own application on your original domain. And another interesting example is creating desktop application. This is interesting because we have now successful of making Streamlit application runs on web browser. Now it can be packaged into a standalone desktop application executable with the power of Electron or Tauri. You can do it just by, some reason it cannot be loaded, sorry, but you can find the README from the ST-Lite the desktop directory inside the ST-Lite repository, and you can simply follow this README to convert your Streamlit application into a standalone desktop application executable like this. So to make it more easy to imagine some actual use cases, I would like to provide some actual examples that ST-Lite is good for. One typical example is the situation where you have to deal with privacy-sensitive data. That's obvious. And also, some restrictive network environment also an example where your clients do not have free access to the internet or some remote host. Especially for non-tech, if you have non-tech users or non-tech colleagues, is a good example that you should use ST-Lite or ST-Lite's desktop application bundler, because even when you create some great tool for your non-tech colleagues, there is still hurdle for them to use your application because they have to set up some Python runtime or access to or some difficult to read URL or something like that. So the last thing you have to do is just package your application into your desktop executable and pass that file to them. That is the thing. And another good example is education. For example, well, to imagine that for university students who are in the course of Python programming, there is still a hurdle, like they have to set up Python runtime on their laptop. So, but if the teacher navigates them to STLite sharing platform, there's everything ready to use. So yeah, these kind of situations are good examples where STLite is good for. But to be fair, I have to say there is some situations where STLite is not good for. This is, are some things that we have to note. One thing we have to note is that source code is not secret, because due to the client-side execution nature, every source code, every source data will be sent to the client side and will be decoded open for your client or users. So please do not use STLite for your cases where your source code itself is secret, or source code includes some secret tokens or some secret credentials, something like that. Also, Pyodide has still some unavailable packages that include some famous ones like PyTorch or something like that. Even though many famous packages are already supported, including NumPy, SciPy, scikit-learn pandas, XGBoost, OpenCV as well. So thanks to the huge efforts by the Pyodide core dev team, there are huge coverage already realized, but there is still a few exceptions. So in that kind of situation, we have to give up, or we have to donate the Pyodide core dev team. All right, so in this talk, let me summarize my talk at this end. In this talk, I first introduced Streamlit as a low-code pure Python WebViewer framework. Then I also introduced STLite. That is a WebAssembly fork of Streamlit that runs completely on web browsers. Also, I demonstrate some applications on STLite sharing web platform. Also, other deployment or development options of Streamlit application using STLite runtimes are available, including self-hosting or desktop application packaging as well. Also, finally, I provided some examples of use cases where STLite is good for and STLite is not good for. This is the last slide. Thank you for listening to my talk. And if you think this talk or this software is interesting, please visit this repository to put a star and also communicate the developer of STLite with me to discuss more features or bug hunts or anything else. Everything is welcome. Right, thank you very much for listening to my talk. Thank you very much.
Thanks so much. If anyone's got any questions, if you want to raise your hand, we've got 5 minutes for Q&A.
So thank you for the talk. It's super cool to be able to run, all Streamlit codes in client side, but I think sometimes you wanna, do web API request. You wanna sometimes use super powerful GPU. Now, is it possible to do HTTP request?
Thank you. Thank you for the very good question. In short, the answer is yes. But there is some, things we have to note. For example, the HTTP client libraries we usually use in normal Python runtime, like urllib or requests, are basically not available on Pyodide runtime due to its internal implementation. Instead, Pyodide provides a wrapper function of JavaScript native fetch function. So other name of PyFetch inside the Python code. So you can make HTTP request from STLite or PyODide applications as just like JavaScript application. Is that the answer?
Yeah, thank you.
Thank you.
Any other questions? At the back. And then,
Hello, thank you for a very interesting presentation.
Thank you.
I imagine that the browser needs to run at least some JavaScript to get the Streamlit data working. So in that case, you end up with two garbage collectors, one in the JavaScript world and the other in WebAssembly Python world. How do you resolve just the fact that these two garbage collectors don't know about each other?
Oh, thank you. So it's kind of a more technical question. Well, the short answer is everything relies on PyODide runtime. To be honest, there is nothing to do on STLite side, because such kind of stuff are handled and managed by PyODide runtime, and it's some library piggybacked to the PyODide runtime that additionally do such kind of, let's say, additional stuff, bridging between JS and Python world. Sorry, so, well, sorry, I cannot provide a clear answer to the question, to be honest.
next question.
Hi, this is Leo. The tool looks awesome. I just want to have a quick question. I noticed you're using OpenCV in Python, where like run some WebAssembly, where OpenCV also has their JavaScript version. It looks like I'm not saying either it's correct or wrong. It looks like people are reaching each other from different directions. From your perspective in the industry, what's a more promising trend or pros and cons of like source codes moving towards front end with native support with JavaScript, or platforms or like WebAssembly, which allows front end to just run Python code or other codes?
Thank you very much. Good point. Well, it depends. And from the performance perspective, I think JavaScript native version will be better because there is no additional layers, right? As a basis, PyODide or PyODide-based frameworks like STLite or something like that is for more entry stuff or just for prototyping stuff or some that fills some gap existing in some such kind of specific use cases where developers are only familiar with Python but who also want to make web-based applications. Well, so if you, so I think both works. Both works in different directions. So yeah, this is kind of a balanced answer still. Well, yeah, as an example of OpenCV, JS and PyODide version of OpenCV are both will be alive, I think.
Thanks.
Okay, that's all we've got time for. Thank you so much for your talk again, Yuichiro. And let's have a big round of applause for him one more time.
Thank you very much.
If there's any other questions, you can hunt you down in the hallway just outside.
And stickers.
And stickers.
もちろん。いっぱいあるんで。あ、もうじゃあこの辺とりあえず1セット。はい、どうぞ。はい、ありがとうございます。西側に。Thank you very much. I'm so glad to hear that.
I was actually trying to use Streamlit, but for rendering data of sensors, but it didn't work out so well.
Oh. That's cool. That's exactly what I'm, good, glad to hear about.
Can we distribute over here?
Right, yes.
Can we take it out to the hallway because we've got to get set up next?
Freely.
seems not working now. Hmm? Yeah, so this is your screen. So
I didn't touch.
Oh, really? Somehow it stops working really.
Thanks. Yes.
Hello everyone, just a quick reminder, if you want to tweet or X or whatever it's called now, you can use the hashtag PyCon APAC for the general conference and PyCon APAC _1 for any talks that are given in this room. Okay, let's start. So we're now going to hear a talk by Prashant Anand, which is called AI for Efficient Routing for Customer Inquiries at Mercari. Before the presentation, the speaker is going to do a quick mic check, so I'm going to ask you to read the mic check text.
Great. Hello, everyone. My name is Prashant. The title of my talk is AI for Efficient Routing of Customer Inquiries at Mercari. My presentation will be in English. The presentation materials are also in English. I will publish the presentation materials. I agree to have my picture taken during my presentation. I will comply with the PyConjp code of conduct.
Thank you. So now we're going to start the talk. In total, it's 30 minutes, so that's 25 minutes of the presentation, and then we'll have a 5-minute Q&A session. So please welcome Prashant with a big applause.
All right. Welcome, everyone, to this talk about use of machine learning for routing customer inquiries. I am Prashant, and I am a machine learning engineer at Mercari. And Mercari, if you don't know, it's a C2C platform where users can list any products that they want to sell, and other users can purchase those products. I work in the customer support domain, so I work on features related to improving the efficiency of our customer support operations so that users can get responses to their inquiries faster. Other than working on AI-related stuff, I really love coffee. So if you are in Tokyo and want to have a chat over coffee sometime, do reach out. You can find me using my handle on the usual places like GitHub or LinkedIn or Twitter. You can find these slides on my GitHub profile, and the QR code will take you directly there. All right, so in this talk, what I'm going to talk about is the problem that my team and I worked on a little while ago. So you're going to see how we found our business problem, and then how we translated into a machine learning problem. And after translating into a machine learning problem, how we solve the problem using NLP and, of course, Python. And since this business problem relates to customer inquiries, you will learn about a couple of algorithms for routing customer inquiries to the CS agents. So in the first part, we will learn about the business problem that we wanted to solve using machine learning. So let's get started. All right, so as I said earlier, Mercari is a C2C marketplace platform. So sooner or later, users are going to face some problems. And when they face some problems, they send inquiries. And to reply to those inquiries, we have some CS agents. So how do we decide which inquiry will be answered by which agent, right? We need some kind of algorithm so that we can decide which agent will answer which inquiry. So first, let's put all of our inquiries into a queue. And the simplest way to do this assignment is something called random allocation. So whenever an agent is, say, available, we look at the top of our queue and just assign that first inquiry to whoever is available, right? So in this case, the first inquiry gets assigned to the available agent, and then that agent starts working on it. And similarly, if some other agent becomes available, then again, we look at the top of the queue and then assign that inquiry to the available agent. Okay, that sounds nice. It's a working algorithm. So let's take a look at couple of sample inquiries that we receive, right? So in this case, the user has a problem with logging into their account. Similarly, sometimes users face problems related to their shipment, so they contact our CS agents for tracking their shipment status. Sometimes they have problem with payment-related things, and sometimes they have problem with some trust and safety issues, like they get some counterfeit items, or the item that they bought was not as it was advertised. So in random allocation, as you saw earlier, like whenever an agent becomes available, we assign the first inquiry that's at the top of the queue, right? So that means any agent can get any of the inquiry that's available. And as we saw in the earlier examples, there are so many different types of inquiries. Some could be about payment, some could be about login issues, and the procedure to handle those inquiries is completely different, right? So agents need to have knowledge about how to handle all of those categories of inquiries. So that's one problem. Another thing is, suppose a new agent joins our team, and before they can start working, they have to learn about each of these procedures because any of the inquiry can be assigned to them. So that's another problem because the onboarding cost of new agent is high. And final is, suppose you want to change the guidelines or the procedure how to handle a specific category of inquiry. If you change those guidelines, then you need to transmit that information to each and every single agent because inquiry from that category, again, can be assigned to any agent, right? So these are some big problems. So how do we solve these issues, right? So instead of having agents know about how to handle all of these categories, we make some specializations, right? So we can be like, okay, this agent will handle issues related to payments. Similarly, other agents can have different specializations, and each of these specializations is called a skill. And one thing to note here is agents can have one or more specializations. Okay, so now that we know that agents have specialization, how do we assign the inquiries? We still need to find an algorithm for routing, right? So suppose we have a black box algorithm, and this black box algorithm, let's say it's a skill prediction algorithm. So you will provide an input, an inquiry, and you provide all the available skills, and it will output an skill that is required to handle the inquiry. So suppose we have this black box. We'll learn more about it later, but suppose we have this. Then we can find what kind of skill is required to handle all of the inquiries that we have in our queue. And now suppose one agent becomes available whose skill is, say, payment-related things, right? So we start at the top of the queue and find the first inquiry that has same skill as that of the agent. So in this case, the second inquiry has payment skill. So that inquiry will be assigned to the available agent. Similarly, the first agent became available. He has they have the refund skill. So we start at the top of the queue and assign the third inquiry, which has the refund skill. So in summary, this is called skill-based routing because you find the skill of the inquiry and then you assign it to an agent who has that skill. So agents can have one or more skills. Inquiry has one skill, and then when an agent becomes available, you find the first inquiry which has one of the skills of the agent and then assign that agent that inquiry. Okay, so far we have a good working algorithm for assigning inquiries, but now let's look into what business problem that we discovered, right? So earlier we saw that we were using this black box algorithm to assign, to find out what kind of skill is required to handle an inquiry, right? But suppose I am a CS agent and I get this inquiry that says, okay, payment skill is required to handle this inquiry, and I have the payment skill, right? So I get this inquiry, I take a look at it, and I'm reading this, and I feel like, doesn't look like it's about payment. Looks like it's about login-related thing, right? So the important thing to note here is that the black box algorithm can be wrong sometimes. So what I do is I take the inquiry, change the skill that is required to handle it, and say, okay, this is login-related thing. After changing it, since I do not have login skill, so I will send it back to the queue, right? So this process of changing the skill that is required to handle this inquiry from one skill to another one, this is called a transfer, all right? So the problem was we discovered that in our operations, we had large number of transfers. So obviously, we want to reduce the number of transfers. So number of transfer in itself is not a good metric to optimize because if you have more number of inquiries, you will have more transfers, and you have lesser number of inquiries, you will have lesser transfers. So you need to do some kind of normalization. So what we do is optimize something called transfer rate. So what that means is, like, say if I'm an agent and I get assigned 3 inquiries to solve, and I have to change skill for one of the inquiries. So that means out of the 3 assignments, I made 1 transfers. So the transfer rate is something like 1 by 3, that's like about 33%. And this is the business problem that we wanted to solve. We wanted to reduce the transfer rate. And before we look at how we reduce this transfer rate, so why reducing transfer rate is important, let's look at that. So if we have to do more number of transfers, then agent need to spend some time making change in skills, and then it gets in back to the queue. So all of these adds delay to the response time. So our customers receive a response that is a bit later, and that is not a good customer experience. So if we want to improve the customer experience, we should have faster response. Another important thing is the agents have to spend time changing skills of the inquiry, which is kind of like a wasted work. So if you want to improve the efficiency of your operations, you need to have a lesser transfer rate. All right, so far we saw like how to use skill-based algorithm for routing customer inquiries, and we also found that we want to reduce the transfer rate. That's our main business problem. So let's take a look at how we can reduce the transfer rate. All right. So earlier we saw an inquiry has an associated skill, and I got this inquiry. So if this skill is correct, I do not need to do anything. And if this is wrong, then I need to make a change, which is a transfer, right? So basically that means earlier we saw the black box algorithm that assigns skill to the inquiries, right? If that black box algorithm works well, then the number of transfer will be less. So if the number of transfers is less, then that means the transfer rate will be lesser, right? So in summary, our business problem is reducing the transfer rate, and to convert that problem into a machine learning one, what we need to do is improve the accuracy of our skill prediction algorithm. So the target metric of this improvement will be accuracy, and when I say we need to make an improvement, then we need to have some kind of baseline upon which we will make the improvement. So in this case, we'll have a baseline skill prediction algorithm, and then we'll make improvement upon that using NLP and machine learning. All right. So before we take a look at baseline algorithm, we have been talking about inquiries, right? So inquiry has 2 parts. First part is inquiry category, and you can think of it as a categorical variable because there are fixed set of categories. And then there is the text of the inquiry. So this is a string, so it can be anything. All right, so let's understand the baseline algorithm through a couple of examples. So on the left, we have our inquiry, and the inquiry category in this case is 4, and then we have some inquiry text. So for baseline algorithm, in the first stage, what we do is we have a mapping of inquiry categories to the skills. So in this case, for category 4, we have the corresponding skill payment. So we assign the skill payment to the inquiry, right? In the second stage, we have a set of keyword-based rules, and in this case, the first keyword rule has keywords login and password, and both of those keywords are present in the inquiry text, so we assign the skill login to the inquiry. Now, if you notice, in the 2 stages, there were different skills assigned to the inquiry, right? So what we do in such a case is the keyword-based rule takes precedence, so the final skill that is assigned to the inquiry will be login. Let's look at another example. So in this case, the inquiry category is 1, and then we have some inquiry text. Based on the lookup table, inquiry category 1 has the skill refund, so refund is assigned to the inquiry. If we take a look at the keyword rules, none of the keyword rules match the inquiry text in this case, so no skill will be assigned based on the keyword rule. So the final skill of the inquiry will be refund. So one thing to note here is that we have corresponding skill for all the inquiry categories, so there will always be a skill assigned based on the first stage. All right, so we saw this is the baseline skill prediction algorithm that we have, and here all inquiry categories have associated skills. So in the first stage, we assign a skill based on the inquiry category, and in the second stage, we check all the keyword rules, and if any of the keyword rules match, then we update the skill of the inquiry based on that rule. All right. So far, this algorithm is okay, kind of sounds good, but there are obviously some problems. So first one is our skills are very fine-grained, so we have a lot more skills as compared to the number of inquiry categories. So many of the skills are not mapped to any of the inquiry categories. Another problem with keyword-based rule is synonyms. So if two different inquiries are about same thing, but they use different keyword, then you need to create keyword rules for each of those different kind of synonyms. Otherwise, if you do not create them, then some of the inquiries will be missed and you will not assign correct skill to them. So in this example, the second one does not mention the keyword login, but it is about login. Another problem is about understanding context. So even though different inquiries can use same keyword, but they can be about different problems. So in this example, both of the inquiries say the keyword login, but they are about different things. So the second inquiry is something about trust and safety issue. All right, so far we saw that our business problem is reducing transfer rate, and to fix this business problem, our corresponding machine learning problem is improving the accuracy of our skill prediction algorithm, and we saw a baseline skill prediction algorithm. So now we're going to see how we can use machine learning to improve upon this existing algorithm. All right, so inquiry has text, so we're going to use transformers for this. You saw the demo of transformers in the previous talk, so I guess most of you are already familiar with transformers. But the overview is that this transformer architecture was introduced back in 2017. It has evolved a bit, but it remains the state-of-the-art architecture for all kinds of NLP tasks. And there are many publicly available transformer models, and good thing is that they are already pre-trained on large amount of text data, so you can immediately start using them. And the best thing about it is it provides contextual understanding of text. So when you try to convert a particular sentence into a vector, then while converting this vector, it takes a look at how each word is used compared to the other words in the sentence. So how this works is, suppose you have some text that you want to convert into vector for some downstream tasks. So first what you do is you tokenize it, and after tokenization, there are some special tokens are added at the beginning and the end to mark the beginning and end of the sequence. And then you encode these text into integers, and then you pass that to the transformer model. And that will give you a contextual embedding or a vector. So at Mercury, obviously, we receive customer inquiries in Japanese, so we need some kind of transformer models which can handle Japanese text. So if you take a look at Hugging Face model repository, there are lots of models available, but not all of them are commercially usable. So you need to check the license and see which ones you can use for commercial purposes. I have listed some of them down here, and BERT models are obviously pretty large. So if you want something that's fast to train and also fast at inference time, so distal BERT models are pretty good for that, and especially the distal BERT model published by Line is pretty good. So if you want to do some NLP tasks using NLP tasks on Japanese text, I'd recommend using this Line distal BERT model. So let's take a look at how this works. Suppose at the top you have this sentence that you want to convert into embeddings. So this text is about resetting the password. So first you have one line to create a tokenizer, and while creating that tokenizer, you just need to provide the name of model. And creating this tokenizer is very easy because we are using the transformers library from Hugging Face. And after creating the tokenizer, you pass the sentence to the tokenizer and you get the output. Again, you need just one line to create your distal BERT model, and you pass the name of the model that you want to create. And after that, you pass the output of the tokenizer to the model, and then you get some contextual embedding. And in this case, for the sentence at the top, you get this 768-dimensional vector that you can use for downstream tasks. Okay, so far we saw that we can use transformers to process our text, right? But as we saw earlier, inquiry has two parts. It has inquiry category and inquiry text. So what kind of machine learning model are we going to use? So in our machine learning model, we are going to have two inputs. One is going to be the inquiry category and the inquiry text. And the output of our machine learning model is going to be the skill that's required to handle the inquiry. So as we saw earlier, we have this text, and we're going to pass it through the transformer to get the embeddings, and we're going to call it textual features. And then we have our inquiry category. We're going to pass it through a simple embedding layer to get the vector, and we're going to call it categorical feature. Once we have these textual and categorical features, then we need to combine them in some way. So there are a few ways you can go about it: adding, concatenating, and there are a few more ways. So in the appendix, you can find a link to this repository called Multimodal Toolkit, and they have a few different ways of combining categorical and numerical features with the text features. In our case, we found that simply adding them was working pretty well. So that's what we do. We add the textual features and categorical features, and we get the combined features. One thing to note here is if you just want to add them, you should have like the dimension of textual features and categorical features should be same. Otherwise, you will not be able to add them. Once you have your categorical features, you can use that to get the predicted skill. So let's take a look at how you can implement this model using PyTorch and obviously Transformers library. So we have this class called DistilBird with categorical. So this is going to be our model that can get the input of inquiry text and inquiry category and can predict the inquiry skill required to handle the inquiry. So in the constructor, we pass some how many dimensions does the categorical input has and what kind of DistilBird bundle you want to use and how many skills are there. And we initialize the DistilBird model. Then we have a couple more layers and their use is going to become apparent once we take a look at the forward pass of the model, but important one is the embedding layer. This is what we use to convert the inquiry category into embeddings or vectors. All right, so let's take a look at the forward pass. So the first two inputs correspond to the output of the tokenizer. So that's the tokenized text, input IDs, and attention mask. And then we have the categorical input. That's the inquiry category. So first we pass the output of tokenizer, input IDs, and attention mask to the DistilBird model, and then we get some text features as just like how we saw earlier. And then we pass these text features through a linear layer and then apply batch normalization and ReLU. Similarly for categorical features, we apply the embedding layer and we get the vector for it. And after that, as I said earlier, we simply just add them. After that, we apply a couple more linear layers, and we get the final output from the final layer. And this final output, the logits that you see here, you can apply argmax over this to get the predicted skill of the inquiry. All right, so now we have seen what kind of ML model that we want to use for this task for predicting skills, right? So before we can fine-tune our model, we need some annotated data, right? So for example, if we have this inquiry and what kind of annotated data we need is for each inquiry, we need some ground truth skills. So for example, if we have this inquiry and we know for sure that this is the skill that's required to handle this inquiry and we have lots of samples like this, then we can fine-tune our ML model. So how do we find what's the ground truth of each inquiry? So suppose I am an agent and I get this inquiry to work on, and then I send some reply to this inquiry, right? So if I'm sending a reply to this inquiry, that means that I have this skill. If I did not have this skill, then I will not be able to reply to this, right? So what we do is we log the skill. Whenever an agent makes a reply to an inquiry, we log that skill in our database, and that skill can be used as the ground truth skill for the inquiry. Okay, so now we have seen how to get the annotated data. So now we can do fine-tuning of our model. The goal is to improve the accuracy of our skill prediction model. And the model, as we saw earlier, consists of two main parts: DistilBird model to extract text feature, and then embedding layer to convert inquiry categories into vector. And then we combine them together to predict the skill of the inquiry. Now data, we gather annotated data from the last year and do something like 8 months of data for training and first 8 months of data for training, then the 1 month of data for validation, and the last 3 months of data for testing. So one thing you have to be careful about here is after you gather the annotated data for last 1 year, don't do random sampling like 70, 10, 20% split for training, validation, and test, because if you when you deploy your model to production, you will not be able to see future inputs, right? So that's why it's important to split your data using time. All right, so far we have seen our business problem, that is reducing transfer rate, and to fix that problem, we developed ML problem that is improving the accuracy of our skill prediction model. Then we saw the baseline algorithm, and then we saw how to solve that using machine learning. Now, after we developed our machine learning model, before we start using fully in production, we do need to see if it actually makes an improvement or not, right? And to do that, we will run an A/B test. So for the A/B test, we have two variants. For the control variant, we're going to use the baseline algorithm that we saw earlier to assign skills to the inquiries. And for the treatment variant, we're going to use the ML model that we just saw to assign skill to the inquiries. And we run this A/B test for 1 week. For metrics, the goal metrics of our A/B test is going to be accuracy of assigning skills, and obviously our business metric, that is the transfer rate. We also need to have some kind of guardrail metrics. So suppose the accuracy of assigning skill improves, but for the cases where we are assigning wrong skills, the number of transfers increase by a lot so that the net improvement is negative. To fix that, to track that, to see that we are actually considering those in our test, we need to have a guardrail about average number of transfers per reply. After we ran this A/B test, we found that accuracy, the change in metrics using the ML model was quite good. Accuracy improved by more than 8%. The transfer rate reduced about 4.7%. And the average number of transfers per reply reduced by more than 26%. So overall, this was quite a good result, and we have already deployed these kinds of models to production, and we have been using these models for quite a while for now for identifying what skills is required for handling customer inquiries. All right, so in this talk, we saw how to route customer inquiries to the CS agents using skills. And then we saw the business problem that was reducing the transfer rate, and then we translated into a machine learning problem that is improving the accuracy of our skill prediction algorithm. Then we saw how to use NLP and machine learning to build a model that can predict skills for the inquiries. And finally, we saw what were the impact on the metrics from the A/B test. All right, that's all. Yeah, I'm happy to share the work done by our team on this problem, and I'd be happy to answer any questions that you have.
So if you have questions, just raise your hands and we'll go around.
Thank you for good speaking. I have 3 questions. The first question is that how the data is balanced, because if the data is skewed, the accuracy cannot be stand as a good metric. And second one is that did you try the conventional machine learning approach, because the text classification has many ways to compare the similar text that can reduce the GPU resources. And third one is that if you have 2 vectors, then you need to find the similar vector. What kind of vector search engine did you use for this project?
Can you repeat your last question?
So what kind of the vector search engine for?
For what purpose? Vector search engine for what purpose? So, I didn't get why we need a vector search engine.
So what kind of vector search engine did you use for that to embedding vector that inquiry and the agent?
To route an inquiry to answer your third question, to route an inquiry to the agent, you just match the skill. You don't need a vector search engine. So,
okay, so I have 2 questions.
Yeah. First one was sorry, can you say that again?
Okay. So how the data was? The data is balanced or imbalanced?
Right.
Yeah.
So obviously, if you check the distributions of the data based on the skill, you get kind of this kind of curve. So we have, for some skills, we have lots of data, and for some skills, we do not have enough data. So what we saw earlier, when we were doing experiments, what we saw was if for any skill we have more than say 100, 150 data points, then after that, the accuracy for that particular skill worked out pretty well.
And the second question is, did you try the conventional?
Yeah, we did try a couple of different NLP-based models using very, very simple TF-IDF kind of thing, or something like very simple machine learning models instead of using transformers. Obviously, I didn't mention them because you need to have some focus.
Okay, thank you.
I was just wondering, with your A/B testing, were they test subjects aware of what you were testing when you were testing your model compared to the baseline?
I mean, this A/B test doesn't directly affect users. So inquiries are assigned to the CS agents, right? So users don't directly find anything about it. So it's more in the background. So when we have our tool where CS agents use to work on inquiries, right? So when they click a button, an inquiry is assigned to them. So they don't know how the specific algorithm is working in the background.
Sure, but did the CS reps know which day you were testing your own versus the baseline?
Yeah, they knew that we were testing these, but individual agents do not know this.
Okay.
Yeah, but do you think knowing about this makes any difference?
I mean, yes, the scientific standard is to do double blind, right? Where no one knows which model is being tested which days.
Right.
That's why I was wondering.
Okay.
Thank you.
Yeah, thanks for the talk. Instead of a question, I think it's just something that I noticed, like maybe a comment. So since you were doing ML and NLP already, perhaps you can do some tagging and clustering of all the tickets that you have, and then come up with a suggestion system in the back to help your customer reps. So when they get tickets coming in, you'll automatically classify and pull out like, hey, related tickets as that we have found before to Easter task.
Yeah, we do not do that yet, but this is one solution that our team has built for making the task of CS agents easier. We do have few more things that we have built, something like building suggestions for when replying to the customers and doing some suggestions there. And we also started using LLMs recently for very, very limited purposes. Yeah.
Hello, thanks for the talk.
Yeah.
Recently, there are large language model appear in the world. I just wondering if you introduce large language model in this kind of problem, what kind of part a large language model can make this system better?
We haven't tried it, so I don't know exactly, but my guess would be, so if you pass this thing to a large language model, you need to pass all your skills, right? And you also, if you just pass one inquiry and all the possible skills, I don't think its accuracy is gonna be high because it hasn't seen any samples, right? So maybe you would need to do few shot approach where you provide few inquiries and all the skills and the final skills. And another thing is the evaluation benchmark for LLMs are still not very mature. So you need to have some kind of things where you can slightly tune the prompt and see does that make a change? Does that make a change? So I think it would make maintaining models a bit more difficult. But definitely as the LLM tools get more matured in the future, we can definitely try this.
Thank you.
I think we can have one last question.
Yeah, maybe on the business decision, right? Normally we will compare between the cost as well as the gain. I see like the gain around 4 to 10%. May I know about the cost, yeah, especially on the compute itself, as compared to the baseline, deep learning as compared to the baseline?
Can you say that again? Like which metric are you talking about?
Compute cost.
Compute cost. So when you talk about compute costs, so there are a couple of different things. Are we talking about the training compute cost? Are we talking about compute costs at inference time? And also, are we talking about it also depends on compute costs are dependent on how much is the RPS that you are serving. So overall for inquiries, we do not have that high of a RPS, right? So we just do inference on CPUs, and using CPUs does not incur high compute costs, so it's fine.
All right, maybe on the, including maybe data preparation, that kind of things.
What?
Data preparation, like cleaning the data as compared to the previous one.
Cleaning the data is not that intensive as well. The fine-tuning, little bit intensive, but since we are using digital BERT models, it's not that intensive.
All right, thank you.
Yeah.
Thank you.
Yeah, for digital BERTs, like you can fine-tune, depending on how much data you have, again, you can fine-tune it for, say, 1 day, and it reaches pretty good accuracy.
Thank you, everyone, for your questions. If you have more, I'm sure you can ask Prashant in private later after this talk. So let's give him a big round of applause.
HDMI? Oh, yes. Here you can use. So, yeah, can you use HDMI? Oh, good, good.
Hi.
Where are you from? Germany.
Germany.
Hi, I'm Hawk.
And I'm Atia. I'm from Canada.
Yeah, I'm also from Canada.
So I can say Hawk and Atia? That's how
Yeah,
I can
yeah,
introduce you? I don't have to do last names too?
No.
Hawk, yeah.
We were wondering
I'm sorry.
about the pronunciation of your name.
Yeah.
Okay. Yeah, Hawk and Atia is fine.
I hope it's easy or not.
That's all right. You can do that.
Yeah. And what's your name?
Ollie.
Okay.
Claire. Yes. Good to be here.
Okay, using Python disease very well.
Yeah, it's kind of like atypical, but yeah.
Should be interesting.
Yeah. Thank you.
So we're going to announce your talk.
Okay.
Basically, Ollie's going to do it.
I'm going to introduce you guys. So just before we start, the first thing I'll get you to do is you can tag team reading it or not. It's mostly to do a mic test.
Yeah.
Okay.
But also explaining the language you're going to use, language presentations, and whether you're sharing slides, whether they're taking your photos okay,
Yeah.
all of that kind of thing.
Okay.
You can answer whichever way you feel.
Okay.
So
Yeah,
Cool.
fine.
Sounds
totally
good.
open. So I'll let you know when it's time to do
Okay,
that.
good.
And also, so you have 25 minutes, and then 5 minutes is going to be the Q&A session.
Okay.
And to help you with the time, I'm going to be on the back and hold up a sign when you have 10 minutes, 5 minutes, and 1 minute left.
Okay.
Just to give you some help.
Sure. Okay, that's fine. Okay, thank you.
Yeah.
Are you okay with it being that mode? Is that how you want to do it?
Do you want the notes to be there or like?
Is that
Oh,
possible?
no, so this is what's
Oh, this is what is
here, so,
like.
Yeah. So it will be, I think, like this.
Yeah. Then what about like?
The notes?
You see the notes already.
Yeah.
Right? Okay. Good.
Okay.
Yeah,
So.
should be fine.
We still got time. I think this is the
Go to the
most
slide which has the notes.
amount of time we've had before. Because the just screen display for 22 and 30 starts.
So we could have done.
We've got plenty.
You are.
Clicker or
Clicker?
Yeah, I'm not sure if we want to use it, but
You are probably going to, well, depending on what you do with the microphone, you'll probably be tied here.
oh, okay.
You can pick it up and but
I
it's not
see.
really
Oh, yeah. Then maybe it's better
think it's
not
better
to use
not to
it.
use
Yeah.
it.
Okay, we're going to be getting started in a little bit, but in the meantime, if you would like to share anything on social media or on Twitter or X as it now seems to be called, you can tweet with the #PyCon APAC hashtag, or if it's specific to this room or talks in this room, then the #PyCon APAC_1. So please feel free to share. Okay, so we're going to get started. So today we have Huck and Atya presenting on using Python for disease variant analysis. Before the presentation, the speaker's just going to read a statement as a microphone test. So we're just going to start that now.
Okay, thank you. So my name is Atya. The title of my talk is Using Python for Disease Variant Analysis. My presentation is going to be in English. The presentation materials are also in English and will be published. And I agree to having my pictures taken during my presentation, and I will comply with the PyConJP code of conduct. Thanks.
Thank you so much. So the presentation time in total is 30 minutes, 25 minutes for the presentation and 5 minutes for Q&A. So please welcome Atya, and you're welcome to get started.
Thank you so much. Thank you so much. Thanks for coming to our talk. And it feels great to be back in PyCon APAC in 2023, because my first PyCon was 2019, before pandemic, so it feels really great. So today, our topic of our presentation is a bit different than what maybe the other PyCon presentations are. It's about infectious disease analysis using Python. And me and my colleague, Hawk Ishfaq, we both are going to show the usability of Python in different steps of the analysis of infectious disease, specifically analyzing variants of different diseases. So just to give you a background about me, I'm a third-year PhD student at McGill University, Canada, and I do my research in infectious diseases, and I specialize in bioinformatics. It's my second PyCon Japan, as I said, but before that, I also attended multiple PyCon conferences in the US. So yeah, it has become already a ritual for me to attend the PyCon conference, and I really, really enjoy it. Okay, so as I said, I'm a researcher of infectious diseases. I work with genomics data, which is a special kind of data. And these kind of data are called next generation sequencing data, for example, DNA-seq and RNA-seq data. So here, what you see on the left side is a very general pipeline, data analysis pipeline of next generation sequencing data. As you can see, there are multiple steps, there are like multiple tools involved in it, and almost in every steps of this data analysis pipeline, you can use Python. And there are already developed, there are different tools that are developed in Python, but I think we need more tools. We need more tools in Python. And the reason I'm saying that, as a researcher, when I work with this kind of data, I always find that most of the tools available are in R, not in Python. So there is not equally, comparably good tools that are available in Python. So what happens is, because as a life scientist, most of the life scientists do not have expertise in programming. So what they do, they cannot navigate through multiple languages. So that is a hurdle. So what they do, they just stick to one programming language, which is R. So that is the reason we should develop more tools in Python to deal with this kind of problems. So the goal of my talk today, our talk today, is first to inform how Python can be used, as a whole, in different steps of this analysis. Second, how Python can be used as a tool for bridging the gap between data analysis, genomics data analysis, and in general life science. We can use Python as a tool for bridging the gap. And third thing is to inform the developers here some avenues where they can work on and improve the already existing tool or develop novel tools, meaningful tools that are of great importance in the domains of life science and infectious diseases. Okay, so as I said, as I showed this pipeline already to you, you can see there are multiple steps of this pipeline, but today we are going to talk about, as an example, the pipeline of variant calling in the middle. But before that, I want to ask you a question, how many of you are familiar with the term of COVID-19 variant? Just raise hand. Oh, that's cool. Most of you do. Yeah, I already expected that we are familiar with the term COVID-19 variant, of course, after the pandemic. But do we really understand what exactly is a variant? How do we define a variant? To understand that, we have to go a little bit back in the background. So this is the double helix structure of DNA, as we know. So DNA is the language of life, language of genomics, and we know that it's double helix. It has 2 strings, but if we zoom in, we will see that DNA is made up of 4 letters: A, T, G, C. Now, we, all living organisms, we all have DNA, we all have genome, right? And we might ask a question how large is our genome, right? So if we think our genome as a book, so there are 6.4 billion letters in our genome, in that particular book. But interestingly, the book you have is different than the book the other person next to you have. So it's not 100% identical. There are some differences. And these differences are called variants. But thankfully, most of these variants are not harmful. They are mostly benign. They are not harmful. But we need to, as a researcher, we need to identify what are those variants that are causing the disease. And that's where we can use Python, and how we are going to show that. So if you want to understand the differences between genomes, like your genome and your friend's genome, what you have to do, you have to first read the book, right? So this is what we do with a technology called DNA sequencing. We sequence the entire genome of the, like, if it is a patient, then the patient, and if it is a, let's say, parasite or a virus, the virus. So we have to understand the entire genome. And to do that, the technology that is most popular is called Illumina sequencing. It can read at a stretch 100 to 200 letters of a genome. And the accuracy is pretty high. It has 99.9% accuracy. However, the latest technology that we have, it can read at least 100 to 300 kilobases of letters, which is pretty like long reads. But the problem is it has 5 to 15% error rate. So the error rate is the problem here. So I'm just like introducing the challenges to you, like what kind of challenges we need to solve. So this is like a typical sequencing output. So when we sequence our genome, we get these small fragments, right, as a DNA sequencing reads that you can see here. And this is like a typical Illumina, like short sequencing reads. What we do after we get the reads, the first task is to align, or is to map those reads against the reference genome. So we all we have reference genome of like almost all of the organisms in the publicly available databases. So what we do, we just map those small fragments reads in the alignment, in the reference genome, and then try to understand what are the differences that we observe globally in our sequencing data compared to the reference genome. So that is basically the task. So here in the example, you see like a simple mapping. You can see the reference on the top, and in the bottom is like a query read. So what you can see that the read is different than the reference in one particular base. You can see that instead of G, it has an A. So that's a very simple variant, and we call it single nucleotide variant. But it can be complicated because these differences can be like longer. Like for example, in the bottom one, you can see that the difference is in 2 bases instead of 1 basis. So there is a deletion. Sometimes there can be an addition as well, like 100 long base pair fragments is added compared to the reference. So that's another layer of challenge. You have to not only take into account the error rate, but also these different type of variants that you also need to identify. So after the alignment to the reference, we get this kind of output in a file called binary alignment mapping file. So here you can see that there are 3 output files, but if we have like 1,000 samples, let's say, we have 1,000 BAM files, which are pretty like large, and that's another issue because it's like huge database or data set that you have to work on. So I already explained a couple of the challenges, like the high dimensionality and the large data sets, and also the error rate of the variants, the type of sequencing that we have, the type of variants that can be present in your sample. All of these challenges needs to be taken care of when we call a change a true variant. Because there is because the important task is to distinguish between a false and a true variant. And that is what is done by a software called Variant Caller. There are multiple variant caller available, and here you can see some example. But recently, one variant caller that is called Deep Variant, which uses a convolutional neural network to tackle this problem. And my colleague, who is a researcher on artificial intelligence in Montreal Machine Learning Institution, so he's going to talk about how this tool is taking all of these challenges into account and calling the variants more accurately. So you can come.
Hi everyone, I'm Hawk Ishwak, and I'm a PhD student at McGill University and Mila in Montreal. And my research focuses on reinforcement learning and bandit. And other than that, I'm also interested in application of machine learning in various domains. And I've been to 3 different PyCon events starting in 2019. And this is my second PyCon JP or APAC. And first of all, I thank the PyCon community for creating an inclusive environment for all of us. So yeah, so let's focus on the challenges of variant calling. As my colleague was saying, there are like millions of samples, and within each sample, there are millions of variants as well. And the issue is like not all of them, all the variants are useful, because like probably like some of them are very low frequency, or like the minor allele frequency is too low, or they are covered by insufficient depth. So it is challenging to identify the important variants from this high dimensional data. And the major challenge here is the accuracy. As we discussed before, the sequencing data can be very error prone. And as you can see here in the example, there are, like against each single reference, there are different multiple variants for each position. And it is difficult to distinguish if these mismatches are random or true variants. And if the variants are false, then there are implications in the downstream tasks, and it can be detrimental to proper disease diagnosis. So to resolve these issues and correctly do the variant calling, there's this tool called Deep Variant, which is like developed by like Google mainly, and it's called genetic variants from next generation sequencing data, and is able to accurately identify single nucleotide variants and small insertions and also deletions from the genomic data. And it uses, at the back of its like algorithm, it uses deep learning based algorithm, and where Python comes in is the TensorFlow library, and as of now is one of the most accurate pipelines for variant calling. So like what is deep variant, right? So at the core of it is basically a data visualization aligned with deep learning. So first of all, like you did the alignments, BAM file, and then use the deep learning. And why do we use deep learning? Because deep learning is very good at classification. So if we can give the genomic data as image input, then we can easily classify them as like different kinds of like variants, like whether it is like a homozygous variant or like heterozygous, or yeah. So there are like 3 different kinds of classification you can make. So one, like the main way we do it is by creating a pile-up image out of the genomic data set, as we see in the middle of the image here, and then after that you just like pass it through the image classifier like deep learning model. So I will like next explain how we make the pile-up image in deep variant. So there are basically like 221 bases, and there are 6 channels deep, as opposed to 3 channels as we usually see in RGB image data. So at the end, the shape of the tensor we have for as input for convolutional neural network is a 100 by 20, 221 by 6 tensor. And the different channels specifies different kinds of data. For example, there are like the first one is about read base, the second one is about base quality, and then mapping quality, and so on and so forth. So here is the overall pipeline of the deep variant. So as you can see at the top, this like you first get like aligned reads and the reference genome, and then you get like the pile-up image as I explained in the previous slide. And once you get that pile-up image, you pass it through a trained classifier, and I'm going to show in the next image like how we train this CNN. And then once you have this pile-up image and the trained CNN, you pass it through it, and then you pass it through this deep learning model for getting the likelihood of it being a variant. right? So this is the high-level pipeline here for deep variant. And for the pile-up image evaluation, we have the candidate side, like the references here, and then you have the reads. And as you can see, the reads can be different, as it can be noisy. Yeah, and the pile-up, then you create the pile-up image. And as I said before, it can have, like, as it has multiple channels, like 6 channels, so it can capture different information, like quality of the genomic sequencing and the error of that, and different sorts of information. And then you pass it through a convolutional neural network. And it can also be pre-trained from, let's say, ImageNet data or so that you can train it in a faster manner. And once you train it, you get an output of like genotype likelihood, which is like, let's say, homozygous reference or heterozygous or homozygous alteration. And in this case, for example, in this toy picture, with 95% probability, it's saying that it's heterozygous. So in summary, like deep variant is an approach that uses CNN to call variants, and like CNN is a type of deep learning algorithm that can automatically learn to recognize features from raw data, as in like image data or genomic data. And in the context of genomic data, CNN can learn complex patterns associated with variants, leading to improved accuracy. And the reason, another reason why deep variant is so successful is that it incorporates an error model that captures the systematic error that's like commonly found in sequencing data. And by understanding that sequencing error, deep variant can differentiate between the true genetic variants and the sequencing artifacts, leading to more accurate variant calling. And also, as far as the training data goes, it's trained on highly curated training data, and the neural network learns diverse and comprehensive training data, enabling it to generalize well across different types of inputs. And the post-processing includes like the refined variant calls and like refined quality scores and coverage and on. Yeah, so that's the story of deep variant, but what's the next thing? So even though deep variant overcomes the challenge of accurately finding variant calling, there are still lots of challenges that are remaining. For example, annotating the functions of defined variants. And after variant identification, the next task is to identify whether the variant can cause any disease or not, or whether it's harmless or harmful. And more sophisticated tools based on machine learning and Python can be is needed to be built to tackle these issues. And then another very important aspect of variant analysis is visualization. And the current methods of variant visualization doesn't allow us to visualize the variants in multiple chromosomes as well as multiple samples accurately. So it requires more Python-based open source tools so that the researchers, especially the life science researchers who might not have like Python background, as most of us here do, can use those tools to accurately identify this, accurately do this analysis. So finally, the sequencing cost has fallen so much over the past couple decades, and whole genome sequencing is becoming so cost efficient that almost anyone can do it. And for applications like personalized medicines and things like that, it will be more and more prevalent. And to tackle this deluge of data that we get from sequencing data, we need to be prepared. And the question is whether we are, as a community, whether we are prepared to help the life scientists to explore these huge data sets using Python-based tools. And that's the question for us. And we need more open source Python packages for helping them to do their tasks more efficiently. Yeah. And finally, we are a group of interdisciplinary researchers. So we come from different countries like Canada, US, and Berlin and UK. So yeah, here's the QR code for our website and Twitter. So if you want to chat with us and collaborate with us, please reach out to us. And with that, I thank you all for listening to us. Yeah. Thank you.
Thanks so much for the talk. If you've got any questions, please raise your hands.
Thank you. So I have two questions. The first one is regarding the reference genome. When you mentioned reference genome, are you referring to the original genome sequence from the virus?
Yes. So the thing is, for the common organisms like human or mouse, like which are used as model organisms, the reference genomes are already available, like from the years of work of life scientists, like before these technologies even got available. But let's say for something that is like very new, like COVID-19, we didn't have any reference genome for that. We had to like first create the reference genome, then we could compare it with the reference and call different version of this genome as different variants. So that's how the reference genomes are classified.
And then if there is a new variant, let's say that you have nowadays there are variants almost every week.
Yes.
So the new calculation of the variant is based from the reference genome, but what if the variant is from one of the other new variants? So how do you track the mapping?
That's a very good question. The thing is, you still compare it with the reference because this is what is the reference point. But you can have, when you do the phylogenetic, like we call it like phylogenetic analysis, we also study the relatedness of different variants, like how closely related are each variants. You have this information as well, so you can always like go back to the tree and then see, okay, my variant is closer to that variant, so probably they are like in the same cluster. So that's
okay, so I have one last question regarding the open source, like we need more open source for this type of stuff. So what are some open problems right now that like there are not enough libraries to tackle?
That's a very good question. I can even like show you an example. So for example, to do the analysis properly, of course, you need to do the visualization properly. And it's very difficult to do the visualization for these kind of results. So in this figure, what you can see, there are like 18 chromosomes from like in the Sarko's plot, right? And each dot represents a variant here. And in each chromosome, you can see how, like what are the variants and what are the positions. But this plot is produced by a package in R. There is no package that can do this kind of analysis in Python. And I'm not saying this is perfect because it can be improved. For example, here you can only compare only 3 samples. You can see in the 3 circles, these 3 samples. But what if you have like hundreds of samples? How do you visualize it? How do you see the differences? Because at some point you want to see whether a same variant is present in all of your 100 samples or not present. So that's like a very open problem that you can work on.
Okay, thank you.
Thank you.
Any more questions? Yeah.
So I've got a couple questions also.
Sure.
The first one was about the pileup images. So I didn't exactly understand what the bases were in the pileup images. Could you go over that again real quick?
Yeah, sure. Okay. I will explain and then you can. Okay, so the pileup image is actually a zoom out version of this image. Okay, so here you see a fragment of reference, very small fragment, and you see fragments of your sequencing reads, that just raw reads coming from the sequencing machine. Okay, so when you have, let's say, 1 million read mapping to the same exact location of your reference, and if you zoom out, then you can get a pileup image like this in the middle, okay? So if there is one particular change, you can see in the middle, the brighter color one. So that is like a gap, probably. Probably that one particular variant is present in 1 million read, like in all of them. So that's why you see this like line. And that's what is captured by the image and goes to the deep variant as an input. So that's like a pile-up image. So what they do, they basically create these thousands and thousands of pile-up images from the reference data set and use it as a training data so that they can accurately predict in the later new data sets.
Okay, so am I understanding this correctly? The individual lines that make up the pile images,
Mm-hmm.
are they the same reading over again?
Not same reading. It's so for example, if you have a sample of a genome, you sequence, and one particular region can be sequenced multiple times because it's random. So ideally, in one particular segment of your genome should be sequenced 100 times, let's say. And you have the control to do that. You can decide whether you want to cover it 100 times, 1,000 times, depending on how much budget do you have. So it's costly.
Okay, so this pile-up then is the sequencing over and over and over
Exactly,
again.
exactly.
Okay, but in that case, since you're using a convolutional neural network, then the data will be almost the same, most likely, I guess, between layers.
So this image will be given as input to the CNN. So what the CNN will try to understand is whether, based on this line or this deletion, whether it should be classified as a appropriate variant.
Right.
Yeah. So it's not redundancy because as my colleague was saying, this is the same sequence, not same sequence, but sequence that captures the same region over and over again based on the random shots of sequences. Yeah. So and when you align them, you get this sort of image, and the whole image will go as input for the CNN.
Right.
Yeah.
So I guess my question is since it's the same sequence, it's just been recorded over again multiple times. So
it's not the same sequence.
It's not the same sequence.
No. The same sequence, as I mentioned, the same sequence is the reference. So you are sequencing the same part of your reference, but when you sequence it, the reads are not exactly the same. You might have errors in one sequence, you might not have error in another sequence. But if you get consistently one change in all of your reads, that means you are capturing something which is truly biologically meaningful, which is not noise. So that's how you distinguish. You are not aligning one same read again and again. No.
Yeah. So each line here, the horizontal line, they are very different.
Yeah.
But this middle line is consistently different. That's why it is brighter.
Okay.
Yeah.
Okay, that makes sense. And then so in this case, you can see this line, so you see this is different. How does the convolutional neural network help additionally to, because if you can see the line already, you know it's different than everything else. So what is the benefit of running it through the classifier?
So even though this is brighter, this can be brighter based on different kinds of changes. So for example, if you see here, right, in this case, all of them are T, but the last one is G. So even for this case, the whole image will be light up, right? But this is probably a good variant because the T here is consistently present in most of the readings, right? But if you see, for example, let's say the first one here, so there's 3 of them is A and the 3 of them is G. So it's 50-50, so it's not consistent. So that's so CNN captures those kind of nuances when it tries to call for whether it's variant or not.
Okay, that makes sense.
Yeah.
Okay, that's all my questions. Thank you.
Thank you.
We've got time for one more.
Yeah, actually, my question is, why do we need to convert it to image since we have the text initially, right? And then since currently, many neural network model, the famous one, transformers, actually based on image, based on text, and then many image now converting to the model.
That's a very good question.
Yeah, that's a very good question. So. Yeah, transformer is one thing that can be used to improve this approach, for example. But like when this deep variant was developed, like CNN was more popular, and like Transformers wasn't there. So and it was easier to create image-based input to give input for a deep classifier, and of course, like it's worth seeing whether text-based manipulation gives higher accuracy or not using like transformers or other like state-of-the-art like neural networks. That can be like good like future direction.
Okay, thank you.
All right, that's all we've got time for.
Okay.
Can we have one more round of applause for Huck and Atia for such a fantastic talk?
Thank you.
If you have more questions for them, try and capture them out in the hallway, and we just ask for cooperation not to gather around the front stage. Our sponsors have booths. Please visit them and run in for the sticker rally to try and win yourself one of the PyCon towels. Thank you.
Okay. So if my voice is not clear, you just let me know.
Hi everyone, welcome again to another talk on track 1. Just a reminder, if you want to tweet about this event or this talk especially, you can use the hashtags which are right in front of there. So today we're welcoming Abe. The title of his presentation is Enhancing Observability in Fast API or Python Application with Open Telemetry. Before the presentation, Abe is going to give us just a quick mic check, so I'm going to ask you to read.
Okay. Hello everyone, my name is Yumin Xu, and also you can promote me Abe Xu. So the title of my talk is Enhance Observability in Fast API or other Python application with the Open Telemetry. My presentation will be in English, and the presentation material will are in English. I will publish the presentation material later, and I agree to having my picture taken during my presentation, and I will comply with the PyCon Japan Code of Conduct.
Thank you very much.
Thank you.
So just to remind you again, this talk is going to be 30 minutes, 25 minutes of the presentation, and then at the end we have a 5-minute Q&A where you can ask any questions you have. So please welcome Abe with a big round of applause.
Okay, again, so hello everyone, my name is Abe Yumin Xu, so I'm a cloud application in Micron, and this is my GitHub and LinkedIn link, and if you want to find the code example later, you can scan the right-hand side of the QR code. Okay? So today's agenda will talk about the observability overview and what is the Open Telemetry, and also how we can apply the Open Telemetry within our application to enhance our observability, and after that we have the demo and Q&A. So let's go start. So in software observability, we often talk about 3 telemetry types, which is like the matrix, log, and trace. So just let me do a first quick survey. How many people have heard about the log and also correct the log within your project? If you already done that, please help me to raise your hand. I think maybe most of people are doing that. Just keep your hand, because I will have a few questions later. So the second question is, how many people already understand the matrix and also correct the trace within your project? Okay, less than the previous one. Okay, how about the trace? Okay, it's very similar with the matrix. Okay, so how many people are already, like, you are able to link your trace, matrix, and log data together? Few of them. Okay, thank you very much. You can put your hand down. Thank you. So I hope after this talk, people will more understand how to apply the Open Telemetry within your project to help you to link those data together. So before that, let's do a very simple introduction. So matrices are numeric value that represent your state or performance of your systems in a particular time. So log are the record of event or message which emitted by a system, and it provides the insight to help you to identify the issue. And the trace is the detailed record of your whole request path of your system, so it helps you to understand your system dependency and also like how your system interactive with other components. So after we have the basic understanding of the trace, log, and matrix, so what is the Open Telemetry? So Open Telemetry is an open source project under the CNCF, and is also trying to build an industry standard SDK. And there are lots of different languages already implement the API for user to use. So the main purpose is we want to link the trace, log, and matrix together. And also it's very easy to use, and also lots of open source instrumentation package are available. So when I talk about open source instrumentation package are available is like if you go to the OpenTelemetry website and click the ecosystem, and if you click the language as the Python, you can see lots of package instrumentation library are available for specific package. For example, if you are using the Fast API, you can find the Fast API instrumentation library right now. If you are using the Flask or you are using the SQL Economy, those are packages currently available on here. You can just download it and include within your project. Then those packages can help you to automatically to instruct your trace or matrix and log information. And this is the status of the SDK and API. So let's look at the overview of the OpenTelemetry architecture. So within your application, based on your application type, you will install different automatically instrumentation library. For example, like the Fast API we already talked about. And you are also able to collect those information by your own by using the OpenTelemetry API and SDK. So after you have this kind of setup within your application will try to send the trace, log, and matrix to the OpenTelemetry collector. Then within the OpenTelemetry collector, you can decide how do you route the different type of data to the different backends. For example, for the time series database, you may use the Prometheus, and for the trace database, you may use the Grafana, Tempo, or Google Cloud Tracing. And for the log, you can send it to the Splunk, or you can send it to a Google Cloud Login or Grafana Loki as well. So it's very flexible. Like after you collect this data, you can use the collector to send it to a different, anywhere, and you will not blocked by the vendor. Okay, so the first one is, how do we instrument trace? So this is the main component within the OpenTelemetry for the trace. So the first thing is we need to initialize the trace provider. And in order to initialize the trace provider, we need to decide two things. One thing is we need to decide what kind of the processor we want to use. And the other is how do we want, what kind of the exporter we want to use. So the processor is take the responsibility to decide how do we want to collect our trace. And the exporter is take the responsibility to determine where we should send the trace data to. So after we determine these two, we can start to initialize the trace provider. Then we can create the tracer from the trace provider and use this tracer to create a span. Okay? So this is just a related, we need to import the related package. And after that, the first thing, in here, I will provide the three examples about like how you can decide like what kind of exporter and processor you want to use. So the first example on here is we will use the console exporter plus the batch processor. So your trace data will be output into your console. So this is very helpful when you want to do some debug. So underline, like we initialize the console span exporter, then after that we provide the exporter to initialize the batch span processor. For the second case, we will use the in-memory exporter plus the single span processor. And so because this data will store in the memory, so it's very helpful when we want to write the unit test to verify our logic. And the third case is we will use the OpenTelemetry exporter plus the batch span processor. And this one will, when we deploy our application to the production, we will choose this way. So after we decide what kind of the exporter and processor we want to use, the next step we will create we can start to initialize our tracer provider. So in here you can see like the 80 span processor, I will equal to the trace processor which we create in the previous slide. And also like if you look at within the tracer provider, there is a parameter called a resource. So this resource can, if you put this resource during the trace provider, so all of the traces created by this trace provider will have this attribute, and later we will look at that. So after that, we will set the global default tracer provider. then we can use the get tracer to get the trace provider. We can get the tracer from the global tracer provider. After we get the tracer, then we can start to instrument our trace data. So we use the tracer.start as current span to create a span scope, and within this scope, you can attach attribute into this span. So for example, like if you want to record some database information, you can put like the select statement or how many row count be insert or be select, be returned during this function. This kind of an example, okay? So if we look at, this is one of the data point from the console output. So within this console output, you can see from the trace information within the content, we got the trace ID and span ID. And on the right-hand side, there is an attribute. You see like is the service.name PyCon demo. So this is, if you remember, this is how we define when we initialize the trace provider. Okay, so currently we have the trace data, and how about the log? So log is very similar with the trace, so we also need to initialize the logger provider, and during the same time, we still need to determine what kind of the log processor and exporter we want to use. And after that, we will create the, we will provide this trace provider to our handler, OpenTelemetry handler. Then after that, within our program, we will create a logger, right? So we will add our handler to within our logger. Then our logger will start to help us to generate a log. So within our log record, if we are inside a scope of the trace, then telemetry will automatically to help us to find the correct trace ID and span ID. So later we will look at it. So again, we import the related package. Then we decide what kind of the exporter and processor we want to use. And it's very similar like previously, console for debug, memory for unit test, and OpenTelemetry log exporter is for production usage. After that, we create a log provider. And so like within the log provider, we have we provide a logger processor and also set the logger provider as a global logger provider. After that, we will like initialize the OpenTelemetry logging handler. So within here, we will provide what kind of provider we want to use. Then we can create a logger and end the handler within this logger as well. So after that, we can just need to, excuse me, then we just need to use the logger as our traditional way. Like we can just use the logger.info, logger.warning, or error to record our information. So you can see this one, this logger.info is within the trace scope, right? So OpenTelemetry will directly help you to find out what is the correct trace ID and span ID you need to use. So if we look at the console output example, on the left-hand side is the log result, and on the right-hand side is the trace result. So if we look at the log result, you can see within the body, this is the message we want to record. And on the downside, we also have the trace ID and span ID. It's matched on the right-hand side of our trace result, right? If you compare the trace ID, they are the same, and also the span ID. So currently, we already have the correlation between the log and trace. And how about the matrix? So OpenTelemetry, they also provide the matrix SDK. And in here, I will just briefly to go through it because currently, there are some challenges on that, and I will talk later. So if we look at the matrix component, it's very similar. Like we initialize the matter provider, get the matter, and create the instrument, and start to measure it. Okay, so this is very similar like before. So this is the log from the matrix. If you use the OpenTelemetry matrix SDK, and you will say, do we find the trace ID and span ID information on here? Do we? No, right? We are missing this part. We only get the value, right? Like in the previously, I
for loop this one to enter the console, and we have the correct value on here, but how about the trace ID and span ID? We didn't find out. This is because currently OpenTelemetry Python SDK haven't implemented. There is a feature called Exemplar, which is come on by the Grafana and Prometheus. So currently, if you look at the documentation, this feature currently is frozen. They haven't implemented yet. So the alternative way is we will use the Prometheus client, which support the Exemplar and provide the trace information when we generate the matrix data. So this is how it looks like. So on the left-hand side, we will create one function. You can see I name it is the generate exemplar. So this one is very simple. It's just a dictionary structure, and we need to have the trace ID and span ID within it. And on the right-hand side, this is how we can use the Prometheus client to create the matrix and also use this matrix to do to measure our systems. So on the downside, like on the last two lines, you can see when we use the matrix incremental, and you can see we provide the exemplar on there. So normally, like the example is just a dictionary, and in here we provide the trace ID and span ID to it. Okay, so let's go to the demo part. So this demo is a Face API plus the OpenTelemetry. So this is the overview architecture. So we will have the Face API service running on the 5000 port. And within this Face API, we will install the related instrumentation library. Like we will use the Face API instrumentation library. And also, we will install the Prometheus Face API instrumentator within it. So this one is underlined. It will use the Prometheus client, and it will help us to export the matrix data on the /matrix endpoint. And after that, it will send the log and trace data to the OpenTelemetry collector. And the OpenTelemetry collector will also help us to pull the data, matrix data from /endpoint. And after that, the collector will distribute the data to the Prometheus, to the Grafana Loki and Grafana Temple. And finally, we will use the Grafana to do the visualization. Okay, let's look at the code a little bit. So this is my Menda.py. So in here, you can see we initialize the logger setting, and also we have the trace setting on here. After we have those settings, then because I already mentioned, we install the Face API instrumentation library and also the Prometheus library on here. And after that, we use the Unicorn to run our project. And on the right-hand side, like after the collector receives the data, it will use like the OpenTelemetry receiver and Prometheus receiver to receive those data. So after the data already on the collector and in the exporter, we can decide like how we want to export our data to. Okay, so we will export the data to the Prometheus and also like the temple and the logi on here. So let's look at the website on here. So this is the Face API website. Okay, so I have two endpoints. One is called a /full and the other is the /bar. And let me just call it right now. So I will call it multiple times. Then also I will call one /full. Okay. And during the same time, if we look at our /matrix endpoint, we can also find the matrix export on here. So if we go to the Grafana page, you can see currently my Grafana already connect with 3 different data source types, Logi, Prometheus, and Temple, right? And after that, this, if I refresh this one, so I already built a very simple dashboard. Let's see. Oh, okay, sorry. Thank you very much. Okay. Okay, let me do again. So we go to the dashboard. This one. Yep, okay, let me zoom in a little bit. Okay, so you can see like there is some data point on here, right? So this is about the request latency. So if we want to see why during this time, like we have the high latency data, we can just click this one. And you can see like this matrix data can provide us the trace ID and span ID on here. So we can use this trace ID and span ID we can use this trace ID to link with our trace. So if we click this one, then boom, it will like provide you to the Grafana temple. So in here, you can understand all of your system dependency, right? Like because currently I only have one service, but if you have more service, you can see more complicated chart on here. And after that, if you want to find a specific log for specific span, you will click there is a log button on here. So we will click this one. When we click it, boom, in here, like you can see, this is the log information on here. So this is very amazing, right? So in the future, if our system have an issue, we can find, like if we find the information on the log, we can use, from the log, we can extract the trace ID and find it on the matrix and the trace as well. But if we find that from the trace, we can use that one to search from the log and matrix. So I hope this one can help everybody can have better on-call life. Yeah, thank you very much.
Thank you. So now we have time for Q&A. So if you have any questions, then just raise your hand and we'll go around.
Thank you for your presentation. Actually, we started to use Fast API recently. And my question is that in your demo, you published your metrics to your Grafana or Prometheus. But maybe this is going to be a very stupid basic question, but is it possible to publish metrics locally as a kind of like a JSON file or something so that we can process them later?
Unfortunately, I haven't looked at that yet. We need to. It's a good question. I need to go to the document to look at that. I know like if you export the log data, it's possible, but I'm not quite sure for the matrix data. Yeah, because like the example the concept is currently is only available on the Prometheus client library. So I assume even you can store it with the local file when the OpenTelemetry collector want to process it. I think currently it cannot understand very well, yeah.
Thank you.
No worries.
Hi, thank you for your talk. Presumably all this logging and tracing generates quite a bit of data. What is a good, as an inexpensive way to store this data?
So like within the trace setting, if you look at their OpenTelemetry website, they have one concept called a sampler. So normally you can determine what kind of the percentage you want to sample your trace data. So like, for example, if you don't want to 100% to correct your trace data, you can set the percentage a little higher. Then you may lose some of the data, but this is very dependent on your business use case. I hope, do I answer your question well? And here.
Yeah, so in this demo, it was basically just one service. So I'm just interested in how the trace ID or span ID, how that correlates with this sort of different APIs, if you have different APIs.
So because, as I mentioned, like currently they are trying to build an industry standard, right? So normally if you are using the HTTP request, then I think most of the package currently they are supported. So as I know, but some of the package, like they don't implement that one, so you need to do some trick on that. So there is one concept called a propagator. So which means like, for example, if you are using the Redis and you use the pop sub function of the Redis, then normally it's not the HTTP request, it's the socket, right? So you are missing the trace ID and span ID. So if you look at some like documentation for this solution, they will ask you to use the propagator and ingest the trace ID and span ID within your message. And on your downstream application, it will need to use the same method to like provide by the OpenTelemetry SDK to parsing it so it can attach it. Yeah.
Any other questions? We still have time.
So.
Okay.
Just give me one. So like in the previously, like the question asked me, like you can see like the tracer provider, there is a sample setting you can set up. So this is the setting about, like I mentioned about like how kind of the percentage we want to collect. So, and currently I think they already is, make it as the environment variable. So you can just set out the specific environment variable they provide. So you can directly change it by your own. Yeah.
Okay, thank you everyone for your questions and thank you for the presentation. So let's give a round of applause.
LT でスピーカーされる方、今日ちょっと HDMI ケーブル系のトラブルが多いので、今のうちに映像テストするためにあちら側のブースにお越しください。For those who present at the LT sessions, today we have several issues on HDMI connection, so please check your laptop at the booth now. So thank you for coming to session 1. So we will start the final LT and closing session from now. So as usual, lightning talk will be performance by 5 minutes, and after 5 minutes I will run some sound. At that point, please stop your presentation. So we will start from Sponsor LT by Google Cloud Japan. Title is Make Your Own Coding Companion with Cody. Speaker is Q-san. So please prepare with connecting your cable. Yeah, please start.
Thank you so much for coming. I'm Tuya. I'm fluent from Singapore. I'm going to talk about this code completion using the Cody. Right? I'm a developer advocate for Google Cloud and focus on machine learning and AI. So anyone talk to the Element and other things before? Like, Bar or any other similar platforms where you have a prompt, you type in, and then you talk to the large language model, then you get better response. Okay? So this is for like other things like, what's my birthday? How do I get, what are the things I should get from my girlfriends and things like that, right? So if you break it down, your prompts into multiple parts, it looks like this, right? You have the instruction, you have context, and then, of course, you have the response, right? In this case, the response is shorter because you are trying to summarize something. It's the same for coding, right? So coding, with Cody, you are still putting in the prompt, and the Cody will give you the code. And of course, not give you your birthday wishes. It will give you code. So this is how it looks like as well. You have the code and the prompt. You still have instruction. You have context. So in this case, I'm generating Python code, and then I will also want to write it in Python and do PEP 8 style guide, right? So this is the response back from the model. So it's fine-tuned to give you the code that you would use in your day-to-day work, right? So currently it's the API. So you can actually integrate this API into any of your work, right? Could be your website, could be your mobile apps, could be anything that you dream to be because it's API, right? You can just assume it and then use it. There are a few things. Completion, which is like autocomplete for your code. You want to generate the whole piece, you can also do that. And you also have a multi-turn chatbot to like ask more about the code, ask it to improve, change the variable names, or add comments and things like that. You can do that as well. Right? You can also check whether the code is actually, if you copy from GitHub, has it been any complication with you and the license that's provided? So you can also do that with the recitation chattings and other things. Right, there's some demo that I have. So I'm going to just switch over to the other tab. So this is how it would look like if you are using Python. Right? I'm using Jupyter Notebook because data science people use that to run it. So you just have to put in like prompt, write a Python function to do binary search, and then you just import the model. Right? So you don't train the model, you don't upload the model, it's just the API call using the SDK. Right? You just say predict, and then you pass in the prefix. So the response looks like that, right? Binary search with the commands and the arguments and returns. And also, it provides some checks, whether the array is empty, whether the middle of the index is the array, things like that, okay? So you can also do it for like Golang, Java, and standard SQL as well, right? So it depends on your use case. You might not just use for Python, you might use for other things. And if we want to control the response, so just now I just asked it to write a Python function, so I didn't define other things like what's the function name, what's the variable name, how many test cases that I want. You can define it in your prompt and say write a Python function, name, calculate cosine similarity, and then it takes in vector 1 and vector 2 as the variable. And you can use numpy dot function. So I'm even influencing how the operation is going to be inside the function to create it, right? So I just have to put in this prompt the same way that we use, and then it will create cosine similarity based on the name that I put in the prompt. And then it will name my variables at vector 1 and vector 2, just as I want it to be. And then what it difference is also use the numpy dot operation to calculate the two. Okay, and it's also produce unit text directly. So unit text here, cosine similarity text for positive, and then text for negative, and so on. Right? And you can also use this as like a template where you have for application already, and then you use this to create some of the things that you want. So let's say you want to generate different functions for different languages. You have just put a variable, like what type of language, what type of format, what kind of extraction, what are the requirements, and then you just create a one string using those variables, and you can change the variable. It could be user input, it could be something that you generate yourself. Thank you so much.
Thank you so much for your presentation. So next speaker is I'm quite sorry.
No problem. Nisanthan Nantakumar.
Thank you. すいません、最初に日本語で全然アナウンスしませんでしたが、今日の最後のセッションの LT 大会とクロージングを始めております。いつもの通りLT5 分間の、トークということで、5分経ったら先ほどみたいに、ドラの音を、流しますので、その時点で終わりとなります。So, next speaker is titled as Test with Confidence, a deep dive into eliminating flaky test in Python. So please start from now.
Good afternoon, everyone. Today we're diving into a crucial topic that often goes unnoticed, but significantly impacts our developer user experience. It's flaky tests. So tests are the backbone of our development process, ensuring our software works as expected. But what happens when these tests aren't reliable? So today I'll be discussing how to find your flaky tests and how we can eliminate them. So my name is Nisanthan. I'm a senior software engineer at Sentry. And let's just keep going. So what is a flaky test? It's a test that can return different results, pass or fail, on different runs without any changes to the code. What causes this unpredictability? There's 3 reasons. Asynchronous code can sometimes execute in unexpected sequences. Race conditions, where the output depends on the timing of uncontrollable events, and environmental factors like differences between local machines and CI. The saying inconsistent results erode trust in a testing system encapsulates our challenge. Without reliable tests, our faith in the entire testing process goes down, and the danger isn't in the false positives, but it's the time wasted chasing down false negatives, or false alarms, sorry. So my goal is to automate the flaky test detection. So the approach is to automatically retry failing tests, and if they pass on the retry, it hints at potential flakiness, and we're going to report that to Sentry. We're going to use PyTest rerun failures plugin and retry 5 times for the system. And so a quick code prototype, we're going to import Sentry SDK, and in PyTest, if you're building a plugin, they have this hook called PyTest run make report, and this executes all the other hooks to obtain the report object. Next, we want to avoid skip calls, and create this attribute called like Sentry exec chain. And this is where we're going to store all of the failures. And when the tests pass, we're going to go through all of those like stored failures and create the exception, right? So put together, it looks like this, but you don't actually need to do any of that work because we built a plugin called PyTest Sentry, and you can just install it and run it in your CI and start collecting data immediately. Once you have all this data, we need a query for our flaky tests. So use Sentry dashboard, and this is actually like an internal screenshot of the stuff that we do at Sentry. And if you look carefully, not only are we recording flaky tests, like doing this system for our backend Django stuff, but also for the front end, React and JavaScript. So this approach is pretty language agnostic. It works for any language and testing framework. And so best practices to fix your flaky tests. Evaluate your test value. So sometimes like the actual value of the test may not be worth the effort to fix the flaky test. So you might as well just like skip, modify, or delete it. Tests should live in their own bubble, untouched by external states and other tests. So PyTest fixtures provide this by allowing you to set up prerequisites and cleaning up after tests. So for example, if you're building a database feature, fixture can create a fresh database instance and tear it down post-test. And also consider mocking external services and dependencies. That way your tests aren't relying on external system state or availability, eliminating an entire category of flakiness. Your test should be laser focused on individual functionalities. If you find yourself writing a test that checks multiple functionalities, it's a cue to split it up. So ensure tests are pretty singular and well-defined, and maintain distinctiveness between tests. Timing can also be a flakiness culprit, especially with integration tests. So instead of arbitrary weights, monkey patch to generate timestamps or date times to emulate certain conditions. And lastly, differences between local and CI environments are a classic source of flakiness. So strive for parity between them. So use tools like Docker. And when you require external interactions, think of ways to minimize variability. And this could be achieved using local stubs or fixtures to simulate external calls. Identification and best practices are just the start, but monitoring is our safety net. So with Sentry's dashboard, not only are you keeping an eye on your application issues, but also any lingering or emerging flaky tests. It's an ongoing process, ensuring that our code base remains trustworthy. Thanks for listening to my talk. Any questions? I don't know. Perfect timing. Let's go.
Sorry, thank you for your talk. And third person is Niharika Badiluri-san.
Okay, sure.
おあれ、一人飛んだ。一人飛んだ。ニハリカ。
Oh, okay. Oh, okay. I don't think quite that. Okay. Thanks for that.
まあこういうことも大体起こりますという。はい。はい。まあちゃんとなんかリストにしてする時間がなかったので、はい。用意できるまで少々お待ちください。すみません、ちょっと後ろ立ち見の方が何人かいらっしゃいますが、前の方の座席結構空いてますので、一番前までお越しいただいてお座りいただけます。So those who are standing at the end, there are some vacant seats at the front. So please come and have a seat. So today we had several issues around our AV system, especially for HDMI connection. So I assume that we may have this kind of long time trouble between LT speakers, but yeah. Actually, today we will have 10 LT speakers in total. Okay, so now it's ready. So next speaker title is Agrobot, Python-based detection device for agriculture. So please start your presentation.
Hello everyone, my name is Niharika and I'm from India. I am an IoT lover and I mostly have my passion and I build most of the stuff which are based on IoT and which help on solving problems of day-to-day lives. And this is one of the projects that we are running with the government of India right now. And this is one of the projects I wanted to show you. That is Agrobot. Basically, we all come from countries where rice and major resource of economy is farming. And I mean, probably in India, mostly I see that a lot of farmers keep toiling the whole, the whole field in hot summer days and day and night without any automation happening there. So when I went to an event, one of the person came up to me and asked, so as an engineer, what are you doing? Why should there be some company coming up and telling you to build this, build that? Why are you not yourself implementing something to improve your country and your own economy? So this is how we came with an idea called as AgroBot, and so that's how the inspiration came up. So we decided to build a bot, I and one of my other friend, this is the 3D KiCad model where you don't need farmers. This particular bot will do the whole work of trying to gain the soil analysis as well as what kind of crop is suitable to grow on a particular soil. So this is the concept and working of the whole bot. It is doing two things. The first thing is navigation, and the other thing is sensor data acquisition. So navigation is, in the sense, it is trying to understand what kind of surface it is, like is it a rocky terrain or is it a smooth surface, something like that. And then it is giving the data to image processing, and that we are doing through OpenCV. And then it is doing sensor data acquisition, that is analysis, and it is done through sensors, temperature sensors, moisture sensors. So it's going to take the data, and almost this is how we got it in OpenCV when we wrote the whole code in Python. So we got the grain analysis, this is how it showed. And through this, we tried to understand what kind of land it was, what kind of soil it was. And then this is how we differentiated in the types of soils that are easy to grow, which kind of crop is suitable for what kind of soil. And so this is the 3D KiCad model, and that's the economical prototype. It's almost like, I would like to show you how probably it can be done. So this is, okay, yeah, can you see the video? So the farmers, they grow and they try to sow the seed, and they do everything this bot will try to do. Using, like, it will just sow the soil, it will even try to, I mean, it will even try to put some seeds into it or something like that. So almost everything is done based on open hardware, sensors, data, acquisitions, and models. So yeah, so that's how it is. The idea is to completely build, and probably many countries like India and countries where the population is huge. It's not every time we have different companies coming up. It's us engineers who can do something, and we get the support of government, and through that we kind of try to do the stuff. So yeah, this is my topic, that is AgroBot. So probably just to reduce the manual labor that probably takes a lot of effort to do, replacing that with technology is what the aim was. And that's how it runs. So yeah, that's my topic.
Yeah. Thank you for your presentation. 飛ばしますか。広瀬さん、はい。すみません。後ろの方で。すみません、こっちのゲインちょっと下げてもらえます。立ってる場所が悪いのかな。では、次の LT ですが、最初リードするイラスト制作実践フロー with Python ということで、広瀬さんにお話しいただきます。広瀬さん、よろしくお願いいたします。
よろしくお願いします。すみません、この、This session is Japanese only。日本語だけでいきます。よろしくお願いします。最初をリードするイラスト制作実践フロー with Python というタイトルで発表させていただきます。私はですね、Python とイラストを愛するとあるもうしがないウェブエンジニアです。趣味でたまにイラストを描いています。で、 イラストレーター支援のための個人活動をしていて、もう、過去に2度ですね、イラストをテーマにした、発表を PyCon でさせていただいています。で、今回で3回目になります。はい、それで、過去の登壇にですね、こんな質問を受ける機会が何度かありました。イラストレーターって、イラストを描くとき、脳内のイメージをそのまま絵にしてるんですかって質問ですね。ちょっとこれ勘弁してほしいんですよね。そんなことできる人、めったにいないんですよ、実は。ほとんどの人が描きながら少しずつ完成形のイメージを構築しているんです。で、イラストの制作フローっていうのが、一般的に5段階あるんですよ。最初に何を書くかを決める着想っていうのできっかけになって、で、ラフをこれでガシガシと書いていって、きれいに線画を整えて、で、その線画をもとに着彩していって、最後に仕上げの調整をするみたいな流れのものをするんです。この5段階をたどりながら、イラストレーターはね、少しずつ完成イメージを自分の頭の中でも、イラストの中でも構築していきます。その中でも、特に色を塗るとき、この色を塗るときっていうのがすごく重要なんです。その時にイラストレーターは自分の完成イメージをぐっと構築することができるんですよ。なので、そんな色を題材に、今回は初歩なんですけども、色選びの話をします。色選びって言ってもね、なんか経験とかセンス必要なんじゃない、難しそうって思うかもしれないんですけれども、安心してください、奥さん。経験とかセンスとかに頼らずに、今回はもう Python を使ってね、色選びをしてみましょうということで、今回はその事例を持ってまいりました。事例って言っても、僕が好きなキャラクターを描いただけなんですけれども、はい、条件としてその事例はとにかくこれキャラクターを描くってことで、モチーフは特定のキャラクターです。で、モチーフが決まったらもう色選びも始まってます。まずモチーフをじっくりと観察して、どんな色で構成されているかを把握します。そしてモチーフの色に合った絵作りのために、イラスト全体の色、モチーフからイラスト全体の色を、絞り出します。そんな時に、よりどころにできるのが、色彩調和理論というものなんですけれども、ちょっとそれは詳細は省きますが、色彩調和を計算するオープンソースって結構いろいろあるんですよ。で、たくさんの色彩のね、配色パターンっていうのが出力されるので、すごくアイディア出しに便利なんですね。で、いろんな可能性がそれで無双できます。で、色彩調和に整って、乗っ取ってうまく絵作りすれば、大抵ね、不思議なんですけれども、ちゃんと映えるイラストができるんですよ。本当にね、約束された勝利の配色が事前に分かるってめっちゃすごいんですよね。はい、これ絵描くけどやったことないって人はぜひやってみてほしいです。はい。で、それからラフの段階じゃなくて、今度は本格的に色を塗り重ねていく段階の色選びっていうのでも検査できます。その一つとして、例として、モチーフに光が当たった時の明部と暗部のシミュレーションです。それはなんだろうな、光源のスペクトルが決まれば大体ね、それってざっくり想定できるんですけれども、ざっくりですね、本当はもう光の入射角とか、オブジェクトの質感とかいろいろ複合的なものを見ないといけないんですけれども、今言ったやつも全部シミュレーションできます。なので、気になる人はとりあえずね、手頃なオープンソースとか触ってみるといいと思います。そして一通り書き終わった後に色全体のバランスを確認できるとさらに安心です。人間ってね、その日のメンタルとか、あと年を取るとね、どんどんね、色の辨別能力が低下していくんですよ。なので自分のね、感覚を過信せずに客観視するっていう習慣がすごく大事だと思ってます。はい、そんな感じで今回は色と Python を題材にイラスト制作の事例を紹介しました。理屈が分かればイラストのレーター目線のコードって結構書けるんで、皆さんやってみてください。あとこの場で言って今日いいのか分かんないですけど、振り込みに出ます。ありがとうございました。
広沢さん、どうもありがとうございました。So next speaker is Chan Sao Yi さん。Please connect your computer to the AV. So the next is Sonny Valdez さん。違う、the next。はい、了解。はい。
これ違うんですか。ちょっと待って。すみません。ちょっと待ってね。
今日意外と結構セッション会場で AV トラブルが多発したようで、ちょっと非常になんでしょう、ドキドキしながら司会をやっているんですが、もともと1時間のセッションで LT プラスクロージングで5分が10人っていうことは50分ですよねっていう。いや、その時点、映ったようですので。
こっち側で全画面スライドショーを廃止してもらって。はい、
はい。Next speaker is Chan Sao Yi-san. Title is How many iPhones does it take to ship a new Python version? Please start your talk.
Thank you. さっきフライングしてしまってすいません。サウイです。I'm an engineer at Henge, based in Japan. So in the past, I've climbed up Mount Kilimanjaro, tallest peak in Africa. Survived COVID. I finished my first full marathon last year, but it's my first time attending PyCon, so very excited to be here today. Thank you. So one more question. What is the difference between an iPhone mini and an iPhone Max, if anyone knows? Okay, I'll just go. Size of an ego, I think. Well, jokes aside, I think even if you're not an iPhone user, you know the new iPhone 15 Neo's coming out, right? Like titanium and all that. But it doesn't really happen for Python, right? Like 3.12 came out in October 2nd, but not all of us knows what's going on, what's the difference between 3.11 and 12, 5 and 6. So I try to dive a little into that and came up with some answers. So, but a primer first on Python versioning. So the latest version is 3.12.0, as many of you hopefully know. 3 is actually the major version, 12 is the minor version, and 0 is the micro version. So to use very crude iPhone analogies, major is like going from an iPod Touch, if you remember that, to an iPhone. So very, very dramatic change, very different things. Minor is like, oh, new iPhone, okay, titanium, very nice. Micro is, oh, new iPhone color. Now you have like military green, so yeah. But there are very similarities, some similarities between Python and iPhone, as I found out. So on the left, everyone knows that guy, Steve Jobs. On the right, many of you know that's Guido van Rossum, founder of Python. He was the benevolent dictator for life at the Python community until 2018 when he stepped down. And by the way, he's still alive. Next similarity, cadence is all the same. Like iPhone, there's a new one coming every year, we all know. And Python, actually, there's a new one every year, right? 3.12 just came out. That's our Wi-Fi password at the venue as well. And pro tip, I was chatting with someone at the Henge booth just now. He was saying, oh, we use 3.7. So quick math, if we add 3 to the 3.7, you know, that's like, oh, he's using iPhone 10. Yeah, right. So some differences as well. So Apple culture, we all know, is very secretive. There's some rumors before WWDC, but you don't really know what's going to come up. But for the Python community is very transparent, it's very community-driven. Everything is on GitHub. Everything is written as a PAP, Python enhancement proposals. So it's all open on the internet, and a PAP takes like from several months to like sometimes more than a year to get accepted or like rejected. Right, and when it comes to the number of people working on Python, at Apple, when I checked, they have 164,000 full-time employees. Obviously, not everyone works on an iPhone, but about 100,000 people working on it, I guess, with the factory people and all that. And for Python, it's actually just 85 active core developers, out of which 5 were elected to be the steering council. So they are the ones who have the final say on whether they want to accept or reject a PAP. And obviously, you have other people in the ecosystem, like library maintainers. So I'll say about 100 people work on a Python version, right? And then finally, when it comes to life cycle, Apple, Apple Care, one year, 3 years if you're lucky, right? Python is designated to have a 5-year window, support window from the first release to the end of support. So, and libraries usually kind of retire support 6 months after the official deprecation. Right? This is a very easy to understand chart. So most of the time, it's very nice 5-year windows, except for 2.7, which lived for 10 years. So it's still kind of haunting us sometimes. And also conclusion, how many iPhones does it take to ship a new Python minor version? So depending on how you measure it, can be like 1 new Python version equals 1 new iPhone, or 1,000th of an iPhone, or like about 2 new iPhones. So thank you for listening to my talk. Henge is hiring. Please drop by our booth. Thank you.
Thank you. Thank you, Chan-san, for your funny presentation. So next speaker is actually Sonny Valdez-san, but Koihoge-san will present for them. ではご用意ください。後ろに立たれている方、前の方とか結構空いておりますので、ぜひ前の方までお座りください。って言ってもやっぱり最前列とかなかなか行きづらいですよね。
もういけてるね。OK。
はい。
OK。
Okay.
The presenter Sonny Valdez was unable to attend due to visa issues. Instead, we will stream 5-minute video that he sent. Okay.
I am going to talk about how to study by making flashcards with Python. What are flashcards? Flashcards are used to help remember words and or pictures. They are helpful for students in memorization. Examples of flashcards are these. So, you can see, this is just a simple card, and we have some text. Iced coffee, caramel macchiato, hot coffee, banana muffin, coffee mocha, pancake, apple pie. Do you all remember all of that? Well, I hope you do, because we're gonna check later. Some flashcards have pictures on them, such as these. We have apple, bee, cat, and duck. But in actuality, we don't need these fancy flashcards. No, we can actually make flashcards with just a piece of paper, such as this. See that? Just write down the text, and you can do a little doodle if you want. However, we're in Python conference, and we want to do this in the digital world. So how do we do this? Before talking about the digital world, here are some tips for using flashcards. Number 1 and number 2, because they're very important, is that you should create your own flashcard. This is what we call a generative learning style, in which you learn something new, and then you write it down. Don't forget to shuffle your cards well, and be consistent in the rhythm when taking time. So, 1, 2, 3, 1, 2, 3, and so on and so on. After you finish all of them, go ahead and recite the words as you remember, as much as you can. Then, rest up for 5 minutes after each session before doing another. Let's make our code. You can find my code here at GitHub. And this is the cafe that we're trying to create. This is the flashcards that we're trying to create. We're trying to use a library called PySimple2. So, we're going to say every 3 seconds, we're going to change the text. That is all this is going to do. Now let's see how it looks like. Sorry about that. Let's try this again. Caramel macchiato, cafe mocha, 1, 2, apple pie, pancake, iced coffee, hot coffee, banana muffin. Do you remember all of that? Well, without looking at the text, hopefully you get 100%. I'm Sonny Valdez, and thank you for listening to my talk. Okay.
はい。だんだんユニークなトークになってきましたが、ありがとうございます。Next speaker is Hassan Saad Ifti-san. Please connect your computer to the cable. So, this is 7th speaker of this lightning talk, so it's already past 2/3. So, next speaker is Hassan Saad Ifti-san. Title is London to Tokyo in 2 hours, a visual demonstration of how Python helps scientific discovery in enabling future passenger rockets.
Thank you so much. Thank you. So thanks for having me here. So I took this very 787 Dreamliner coming here from Los Angeles to Tokyo. It took a long 12 hours to come here. So imagine a world where wherever you go, it will take 2 hours. Imagine going from London to Tokyo within 2 hours. Imagine a world where you need to transplant a liver. So you take a liver from one donor living in America to, say, a donor living in Japan within 2 hours. So from donor to receiver within 2 hours. So we're looking at a passenger rocket. But why can't we do that? So if we were to use one of these aircraft just for once, it will cost a ticket, a general ticket, about $1 million, because these aircraft cost about $300 million US. They can carry 300 people. So roughly speaking, if we only use it once, the ticket price would be $1 million. And that's what's happening with rockets today. So let's have a look at the speeds of flight today. So when we fly today, we fly at 87% of the speed of sound. We had the Concorde that took us from New York to London within 3.5 hours. So that's supersonic, actually Mach 2, so twice the speed of sound. So if you're looking at passenger rockets, we're looking at hypersonic speeds. So anything beyond Mach 5, so 5 times the speed of sound. So what's the problem here? Why can't we have passengers, daily passengers in rockets? So the challenge we face is heat. So when you have friction, it generates heat, right? So if you're coming in very fast, it generates a lot of heat. It heats up the air, surrounding air. And this is actually a SpaceX capsule coming in. This is real data. Now, when they come back, you can see that it's already charred. It's damaged, so we can't use it again. This is the NASA Artemis program. It will take us to the moon, but it's not reusable. If we want to be like Top Gun, fly at high speeds, this could be a future aircraft, but it will be very hot, you can see here. So these methods are not reusable, so we can only use them once. So we're looking here at a new technology, a reusable technology, that's transpiration cooling. So we mimic how we sweat. So this is going to be a sweating rocket. So this is the vehicle skin. We inject some cooling gas through a porous material, and that will keep away the heat from the wall. So this is mimicking our skin. So that's where we inject the gas. So what we want to understand is how this protective gas mixes with the hot gas, because we want to know how much we need to carry. Because in an aircraft or a rocket, we have to know how much we carry, its payload. So for that, I did experiments. So this is a hypersonic tunnel at the University of Oxford. So it does Mach 7. So it's 7 times the speed of sound for 30 milliseconds, not seconds, milliseconds. So we get real-life data from these tunnels. So that's the model I'm testing there with my crazy scientist hair. So I'm putting in this model, and this patch of pink, say, paint here measures the concentration of gas. So I'm injecting nitrogen and helium, and I'm measuring the concentration of the gas with a high-speed camera. Remember, it's 30 milliseconds, so the camera needs to be fast. So we get a time series data, block of data. It's about terabytes of data, really. So that matrix of data goes through several processing routine using NumPy mainly. So we do a stabilization, we apply the calibration pixel by pixel, and get the concentration. And I'm going to show you the concentration in terms of relative concentration. So eta 1 means 100% of the injected gas, and 0 means there's no gas anymore. It's all mixed away. So this is the real-life data happening at 7 times the speed of sound, at Mach 7. This is real data happening. So one thing I want you to appreciate here is every pixel is a sensor. It's not one sensor, 2 sensor. All of the pixels are sensor. This is real-life data. So what do we do here? So if I, okay. So we take that map, and then we take a span-wise average, and then we create line plots. And our goal is to predict this, because if we can predict this, we know the physics of it. So we come up with a fluid mechanics-based hypothesis based on diffusion, and this is the physics of it. And then now we compare it to the experimental data here. Now you can see the dashed line is the analytical model. So this is the theoretical model. And now you can see that the experimental data is pretty much on top of. Okay, thank you.
Yeah, thank you, Hassan-san, for your presentation. So next speaker is Grass Monkey-san. 準備をお願いいたします。グラスモンキーさんの次、next to グラスモンキーさん is Patty Wong さん。Please be prepared. というところで残り3人となってクロージングも近づいてきておりましたが、皆さん今日どうでしたでしょうか。意外とノリがいい方々ばっかりで意外といろんなところで LT の司会やってるんですけど、なかなかノリが良くないと乗ってくれない方というイベントもあったりしてちょっと辛かったりはするんですが、では、準備できたようですので、グラスモンキーさん、タイトルパッケージ管理ツール来園の旅路ということで、LT いただきます。よろしくお願いいたします。
よろしくお願いします。はい、今回は、我々日本語でいきます。でも一応スライドは英語で頑張って作りましたが、文頭はちょっと日本語になります。よろしくお願いします。で、今回のテーマはLAI っていう、パッケージマネジメントパッケージツールですね。今日もなんかたびたびトークとかで出てた気がするんですけど、それの紹介になります。で、自己紹介ですが、普段はPHP とかを書いてて、最近は WebAssembly 使ってブラウザで PHP を動かすとかを作ったりしてました。はい。で、今回ですね、なんで今回PyCon のトーク今回初めてなんですけども、普段仕事でよく使ってて、なんか環境構築で結構苦労することが多かったので、今回ちょっとそれでチャレンジしてみましたみたいなトークになります。で、そもそもLAIって何っていう話になるんですが、個人で作られたものがベースになるんですが、スターもだいぶもう多くなって、だいぶデファクトになりつつあるのかなっていう、ラスト製のツールになります。で、大きい特徴としては3つあるかなと思ってて、ラスト製であることと、PyProject.toml ですねを使うっていうところと、あとはあんまり今回触れないんですけども、透過的にですね、VEnv を使えるみたいなところが特徴かなと思います。で、ラスト製であることが何が嬉しいかみたいな話で言うとですね、シンプルであることになるかなと思います。で、どういうことかっていうとですね、環境構築がすごい楽かなと思います。いろいろバリエーションあるかなと思うんですけど、例えば PIP と VEnv の組み合わせとかだと、Python 入れたりとか、あとはアクティベートしたりとか、なんかいろいろあるかなっていうところで、私みたいな初心者だと結構ヒーヒー言うかなっていうところになります。で、あとはポエトリーとかっていうのもあるかなと思うんですけども、これも最初に Python 入れる必要があったりとかで、なんかそのバージョン何にするのみたいな結構悩むことはあるんじゃないかなと思います。で、一方で LAI だとラスト製なんで、インストールして終わりっていうので、簡単でしょってやつですね。はい。で、あとはロックファイルも作られるんで、インストール時の状況再現とかもすごい楽かなと思います。当時でシンプルにセットアップができるんで、やったぜっていうことですね。最近だとやっぱ MR-Mac とかApple Silicon とかの登場で CPU アーキテクチャの違いで結構悩むことがあるんじゃないかなと思うんで、そういうのが少しでも減ることができるのはいいかなと思います。で、あとですね、PyProject.toml の触り方みたいなところで言うと、PyProject.toml 自体は皆さんご存知かなと思うんですけども、4種類の PEP で定義されているものかなと思ってます。で、それぞれちょっとLAI とですね、ポエトリーの比較をしてみると、LAI はこんな感じで、プロジェクトに基本的な環境依存を書いて、独自拡張の部分に開発用の依存を書きますと。で、一方でポエトリーは全てが割と独自拡張かなっていう感じのがちょっと違いとしてあります。で、総じてそれらが、ファイルとしては別だったりするんで、ちょっとこのマイグレーションどうすんのみたいなのがちょっと疑問にあるかなって私は思いました。で、具体的なマイグレーションツールが公式では提供されてないので、今だったらどうするかっていうちょっと自分なりの解を提示してみるんですが、リクエストメントテキストを間に経由することでマイグレーションはできそうだなっていうところは一応確認できました。はい。で、ちょっと本来ですね、今回のトークとしては実際プロダクション導入してみたちょっと知見とか話せればよかったんですが、ちょっと時間がなくてできませんでしたってことで、ちょっとブログというか続きはウェブでということで、お待ちください。はい。で、まとめになります。 ライを使うですね、環境構築がすごいシンプルになるよっていうのと、あとは PyProject っていう基本的な PEP に基づいてやってるんで、スタンダードだよねっていうのが安心感があるものかなと思います。で、あとは私みたいに Python 普段触らない人からしても、透過的に今までの Python の仕組みを使ってくれてるんですごい安心感があるプロダクトだなと思うんで、今後ぜひ使っていきたいなと思います。はい、いろいろ欠けてるかなって思う部分もあるかもしれないですけど、オープンソースなんでぜひ皆さんコミットしていきましょう。私もやっていきたいなと思いました。はい、最後に PR です。採用もやってるんでちょっとよろしくお願いします。はい。
はい、グラスモンキーさんありがとうございました。So next speaker is Proti Wong san. Please prepare for your presentation. So the last speaker is Sojin san. Yeah. Okay. Yeah. Slide is now on. So next is by Petit Wang San. Title is Evaluation of Ranking Model. Please start your presentation.
Hello everyone, my name is Petri Wong and my topic is how to evaluate the ranking model. So who am I? I'm a machine learning engineer for search engine AI. I work for the Legal on Technology, which is a company help users to review their contract and identify the potential risks in the contract. So my job is help users to retrieve contract or articles. Or in other words, I build ranking model for the search engine. So what is the process for building the ranking model? So we will read the paper, get some idea, and try to build a POC model and do some benchmark many times, and on the which is on the static data set. And after we prove our new model is better than the existing model on the benchmark data set, I will do the offline evaluation several times. So we submit the query on the production data and try to retrieve the result and ask the domain expert, which means lawyers in our company, which model is better than the other one, the baseline model or the new model. And after that, if we prove it is better than the baseline model, we will try to implement it in the production environment and try to do some online evaluation, such as A/B tests. And so what is the cost of the evaluation? So for the benchmark, we can integrate them into the CI/CD or MLOps, and it will take something like a few minutes to 1 hour if the data set is super large. For the offline evaluation, we will put the result on a web interface, or sometimes we just simply put them into an Excel file or a spreadsheet. So it will take a few hours if our lawyer work very hard, or days, or even weeks if they are very busy. So for online evaluation, it usually take around 2 weeks or more, because we need to collect enough sample size. And we want to eliminate the weekday effect, so at least 2 cycles, which means 2 weeks. So for the benchmark and online evaluation, we cannot help them because we cannot ask our user to submit more query into our system, and we cannot. The benchmark is fast enough, so we will not focus on that. For the offline evaluation, so it is how we will do that. So we will try to have n preset queries and generate some result from different model, and ask our college, which means lawyers, to give them a score and aggregate the result and calculate the win rate. And in this test, we found that the model A is better than model B, but however, model B is our new model. and I need to go back and change some hyperparameters and generate another set result and wait for 1 more week. So what's the solution to make make it faster? So the first solution is to ask our college to work harder, and and don't sleep, something like that. And another one is import OpenAI and try to write a prompt here and write a Python program to feed our data into the prompt. And it will generate something like here, the score for model A and score for model B in each query. And we aggregate the result and calculate the win rate and get the final report. And the next step will be integrate this one into our ML logs and repeat the evaluation many times with different hyperparameters so that we cannot, our lawyer can just go to sleep. Okay, and the final one is pay the bill. Thank you.
Thank you, Petri-san, for your presentation. So the last speaker is Sojin-san. So please connect your computer. Like 日本人っぽい名前な感じがするけれども、どっちかわからないっていう時怖いですよね。そう。いや、なんか先ほどから全部でスマホでやってるんですが、さっき私のスマートウォッチの電源が 0% になって時計がこうピンチというか、いや前回 3週間前のペチコンで何を学んだ私はっていう。はい、So the last speaker is ソージンさん。タイトル違ったようです。はい。いや、3週間前ペチコンで LT の司会やった時全部スマホでやってて、なんかアプリを切り替えないといけないってなって、次回は絶対印刷してくるぞって思ってきたんですが、今日 LT があると私は把握していなかったという、こういうオチで今日また全部、しかもドラもない。はい、So the last speaker is Sojin Yoon-san. Title is Time to Save CI Time. So please start your presentation.
Hello, I'm Sojin Yoon, a Python developer working for the OTT company Laughtel that streams anime in Korea. Nice to meet you. Today, I'd like to talk about how I managed to reduce the CI time. お願いします。Once upon a time, I was happily coding as always. I noticed that my CI process was taking around 11 minutes to complete whenever I pushed to GitHub. So, what's the CI? Let's briefly learn about the CI, continuous integration. According to Red Hat blog, the CI is an automation process for a developer. Successful CI means new code changes to an app are regularly built, tested, and merged to a shared repository. It's a solution to the problem of having too many branches of an app in development at once that might conflict with each other. So 11 minutes. The 11-minute time may not seem too long. However, what if you had to fix just before a deployment? And what if something that worked perfectly on your local environment broke only in the CI, requiring you to make corrections, push again, and wait? If this cycle repeats 2 or 3 times, you could easily lose about 30 minutes. If multiple developers push to GitHub several times a day, it will take more time. So how to solve? I started looking for ways to reduce this, believing there must be a solution, and I can proudly say that I did it. The CI time has been reduced to around 1 minute. Here's how I achieved it. Caching. Cache things that don't change frequently. Parallel processing. If possible, parallelized tasks. It's simpler than you might think, isn't it? As always, there were so many trials and errors. At first, I implemented a mechanism to detect changes in migration files because I'm using Django, and used caching when there were no changes. Additionally, I tried running it with the parallel option, and it worked well locally, but for some reason it was breaking in the CI environment. So I ended up using this approach. As there was no need for the migration process in the test, I boldly omitted it. It's the configuration. So simple, isn't it? Migration first. And test splitting. Instead of using this parallel option, I ran 2 containers in parallel. I experimented with up to 5, but it didn't significantly reduce the time. So I'm currently running with 2. The configuration is simple. You just need to add the following to your CI config file, in my case, Sucker CI. It may vary depending on the environment. Parallelism 2, or the desired number, whatever you want. This allows you to run tasks in parallel, which can help speed up your CI process. In conclusion, the time was reduced 1/10, and the cost also became 1/10. You can do it too. Give it a try, and I hope it helps you save time. Thank you for your attention. My Twitter and GitHub accounts are as follows. Even though I mainly use Korean, I've been studying English and Japanese, so I hope to be able to communicate in various languages. I'm really happy to have had this lightning talk today. I wish everyone a happy day. Thank you.
Thank you, Soji-san, for your presentation. So, series of lightning talks of PyCon 2023 Day 1 is over. Please give warm hand clapping to all 10 speakers.
はい、皆さん、今日の Day1 の、参加お疲れ様でした。ありがとうございます。今もたくさんの LT の方発表いただいて、もう短い内容、時間ながらももう内容がもう濃くて素晴らしいなと思いました。また内容に興味あった方がいましたら、ぜひ近くにいらっしゃると思うので、ぜひ交流、コミュニケーションという意味で交流して、いろんな知見を増やしていってほしいなと思います。まだどのくらい？あと少し。
Yeah, okay, we will just wait a little while people move between different tracks. Because of something that will happen at the very end of the closing. So that's top secret, but you can get excited for what that surprise will be.
大丈夫です。いつでも。はい、ですね、もうすぐクロージングを始めたいと思いますが、その前にちょっと運営の方で、いろいろと準備もしてたりするので、もう少々お待ちください。 この後ですね、内容には含めてますが、記念撮影もしたいと思ってますので、ぜひ皆さんでこの場でいる方、写真撮りたいと思ってますので、ぜひ写真 NG じゃなければ、ぜひみんなで一緒に写っていただきたいなと思います。
Yeah, so those of you who understand Japanese will now know what the secret special event at the end of the closing is. And those who don't, now is a good time to start learning Japanese. Like talk to your neighbor, they might be able to help you.
全然話せますけど、どのくらいあ、いえ、全然大丈夫です。じゃあちょっとこの待ってる間ちょっとトラック1の、方しか私は見えないんですけども、トラック2も見えてるのかな。今回 PyCon 初めてという方っていらっしゃいますか？ざっくりアンケートで。
First time PyCon attendees, raise your hand. I'm not allowed to raise my hand, but
おお、すごい。
半分ぐらい。
ありがとうございます。そうか、嬉しい。で、今回 PyCon APAC としては10年ぶりですね。10年前に2013年に PyCon APAC があって、ずっと PyConJP としてやってたんですけども、今年は APAC として、アジア地域です。アジア太平洋地域の人たちが集まるようにという思いで、ちょっと国際色をより一層国際色を出してやってきました。
長すぎ。
すみません。あ、いいよ、じゃあ続け。じゃあちょこちょこ振ればいい。漫才じゃないですよ。どういった。PyCon APAC は10年ぶりです。わかる。
And yeah, we're really happy that we can, after 10 years, again host PyCon APAC here in Japan, as opposed to PyCon Japan that we do every year, which, by the way, we do again next year. Just a little hint. You might want to come again.
じゃあもう一個、ちょっと簡単なアンケートというか聞きたいんですけども、今回日本以外から来られた方ってどのくらいいらっしゃいますか？日本以外から来られたという方は手を挙げてください。
Anybody who came from outside Japan, put your hands up in the air.
あれ、こちらはちょっと思ったより少ない。
Oh, not
じゃあ
that
日本に
many people here.
日本に住んでいるし、なるほどなるほど。もしかしたらトラック2の方かもしれないですが多いかもしれないですね。なので、はい。はい、アンケートありがとうございます。ですね、じゃあそろそろ OK かな。はい、では改めまして、クロージング PyCon APAC2023 のクロージングを始めたいと思います。
Okay, so yeah, sorry for the wait, and we will now start the day one closing of PyCon APAC 2023.
はい、今回のインポータントアナウンス、重要なアナウンスなんですが、英語で書いておりますが、お詫びとご案内となります。本日、運営側としていろいろと準備、最善を尽くしておりましたが、映像配信とか機材トラブルとか、登壇者の急なキャンセルがございまして、運営としてお詫びいたします。申し訳ございませんでした。
And yeah, we would like to apologize for some of the trouble that we had today with the scheduling and all of that, and we thank you for your understanding.
はい、あともう一つの案内ですね。はい、すみません。そうか、そういうこと。
これが去年。
すいません。もう一つの案内です。これは今日参加された方は明日も使えますので、明日参加される方は名札とストラップを一緒に持ってきてください。
And I would like to add once more apologize because we forgot to change the speaker notes from last year. Anyway, please bring your lanyards and name tag again tomorrow. You will need them to get into the venue.
もう一つですね、案内ですが、午前来たときに、ノベルティのステッカー、皆さんに配るステッカーが準備できてなかった点がありまして、参加者全員に渡せるものとなっております。お昼休みに配ってはいたんですが、まだ受け取ってない、もらってない方は、運営の方までお声掛けください。
And yeah, we intended to give everybody some novelty stickers in your bag in the morning, but the stickers arrived too late, for which we apologize. And during lunch, we tried to hand them out to as many people as possible. If you have not gotten your fancy stickers yet, please get them at the HQ.
続いて、忘れ物、落とし物です。
Okay, we have two things that people forgot. Somebody lost their memory.
なんかこのメモリなんで落とすのかな、なんかすいません、なんでノートパソコンで来られる方がいらっしゃったんですが、これ取り付け。
It has a hole for, it seems to be a key holder or something. And it was lost in East Sponsor Hall at around 4:30. If you lost your memory,
もし
please either come here right now or come to HQ later.
はい、もしここあたりある方は、こちらまでご申告ください。
Number 2, a very beautiful bag, a very unique bag that very few people have at this venue. And this was lost just a little half an hour ago in track 3, last row, left side. I don't know left side from this view or from this view. I don't have that information. If you lost your novelty bag, please go to the staff HQ to get it.
はい、こちらのノベルティのバッグ、トートバッグないなと思った方がいたら本部まで、お声掛けください。続きまして、アンケートのお知らせです。こちらのアンケートは、Day1、Day2 含めてお一人様1回、アンケートいただきたいので、今日参加して明日参加されないという方はぜひ今日アンケートをお願いします。なお明日も参加して、明日参加されますという方は一応メモをしていただけると嬉しいです。でまた明日も案内いたしますが、この2日間参加されてそれでのアンケートですので、アンケートのご協力、今日参加して明日帰っちゃうという方はぜひアンケートのご協力をお願いいたします。
To allow us to improve the conference year after year, we would really appreciate it if you could answer our survey. However, if you join us again tomorrow, please answer the survey after tomorrow. If you only join us today and cannot join us tomorrow, please answer the survey after the closing. Thank you.
はい、続きまして明日のセッションについてです。明日はですね、Day2 キーノートスピーカーとしてロレーナさんがいらっしゃいます。今日先ほど私もお会いしたんですが、ロレーナさんがいらっしゃって、朝10時からですね、この会場にて、発表いたします。
And yeah, tomorrow's keynote will be Lorena Meza. She will have the keynote after the closing, the opening, that will start 10 a.m. tomorrow.
はい、明日のトークセッションについてですね。明日は5トラック、5トラックで28トークを予定しております。場所についても同じですね。今日と同じで、4回は4トラック、5回に1トラックありまして、合計で28トラックを予定しますので、ぜひお楽しみに参加ください。
And just as today, we will have 5 tracks tomorrow, but unlike today, we have 28 talks tomorrow, which is one more reason to come to go tomorrow.
はい、続きまして、オフィシャルパーティー、公式パーティーの案内です。すでにもしかしたら申し込みしている方はご存知だと思いますが、今年も、こちらの会場ですね、20階にて公式パーティーがございます。
And yeah, tomorrow, after the conference, we will have the official party in this venue on the 20th floor. There's very few tickets left, so if you have a normal ticket but you don't have a party ticket, you can still get one, and the system should now work where you can actually add new stuff to your ticket. So in your Pretix email, you should be able to go to your order page and add the party.
続きまして、その明日の、パーティーの中でライトニングトークを予定しております。こちらは事前申し込み制ではなく、もうその場でやりたいと思った方、おおよそ5人ですか、5人5スピーカーズということで、きっかりという感じではなく、もう今回もともとこちらのトークセッションでの LT は事前申告制 なっておりますが、こちらはもう本当に自由にその場でやりたいと思った方が申告していただいて、そのパーティー会場ですね、パーティー参加者だけがトークできるような形を準備してますので、LT やりたいという方がいましたら、その場で設定している、もしくは案内されたスタッフにお声掛けして、LT トークお待ちしておりますので、よろしくお願いします。
During tomorrow's party, we will have some time and space for people who want to give a lightning talk. The way that works is you're going to sign up during the party. There will be an announcement on how exactly that works. We haven't figured it out yet. And this will be in person only, not streamed, not recorded, so like a unique chance to experience those lightning talks.
はい、続きまして、29日スプリントデーですね、日曜日になります。今年も開発スプリントですね、各リーダーがある題目に沿って開発を進めていく、そのチームを作って進めていくスプリントです。10時から17時、渋谷にある変化株式会社さんで行われます。こちら登録制なんですが、事前登録制で、入れますので、ぜひ登録の上、ご参加ください。
And as a reminder, once again, there's a sprint on Sunday. It's going to be from 10 to 5. And importantly, as I mentioned this morning, this is not in this venue, but in a completely different part of Tokyo, in Shibuya. It's free to attend. There's going to be free lunch, but you have to register in Pretix. And again, you can do that through your order page and add the sprint option. There should be some slots left. Okay, and so here's the secret super special event that I teased before, and that is we're going to take a picture. And the way that is going to work is we're going to take pictures in multiple rooms because we don't have a room that's large enough for everybody.
はい、続いて、写真撮影に移りたいと思います。ですね、今回ちょっと会場がそれほど広くない区切られてますので、2回に分かって2回と言います。皆さんは移動はしなくて大丈夫です。カメラマンが移動して撮影します。で、方法としてはまずこちらトラック1で私も含めて皆さんで撮影します。その後トラック2にいる方が、トラック2で撮るという形で、ちょっと全体の集合ではないんですが、1、2で分かれて集合写真を撮ります。で、撮影に関しては今こちらにカメラマンさんがいらっしゃいますので、そちらの、案内に従って、撮影いただけると幸いです。では行きましょう。
And so the way this works is you don't have to move, the cameraman will move. So we will first take a picture in room 1, then we will take a picture in room 2. So now, room 1, everybody get ready, pose.
もうちょっと大丈夫そうです。私その辺入りますね。ここちょっと大丈夫そうです。はい、大丈夫。彼女はもうちょっと変化のお姉さんもうちょっと名前が大丈夫です。ここに行きたい。美味しい。
Thank you. And yeah, track 2 people, please wait a little bit while we come over.
トラック1の皆様、本日はこちらで終わりますので、もう皆さん書いてる方もいますが、お気をつけて、明日もありますので、ぜひ明日皆様お待ちしてますので、また皆さん明日会いましょう。今日はお疲れ様でした。
And yeah, track 1 people, this is it for today. Thank you very much for your cooperation with the pictures. If you want to be in both pictures, you can probably sneak into room 2. If not, take care and see you tomorrow.